kind of the implementation of the data side is a topic for another day. The metadata is what I'm going to talk about. So we saw that in a metadict object, which is essentially a dictionary that has a few other add-ons. So it has case insensitive indexing, and it now tracks any changes that are made to it. Those are the two big things I can think of off the top of my head. And then we also have a dictionary of plot settings which tell the map how it wants to be plotted. So that's color map, the norm, and stuff like that. So I'm going to talk about metadata. So the metadata is in a .meta property, and essentially at the moment it's just a dictionary of fits metadata. And so just having a dictionary of fits metadata is kind of not the most user-friendly way to do it. So on top of this, we have a load of properties on the map, which basically provide an abstraction layer above this dictionary. So kind of taking the fits metadata, which is all in strings, and returning Python objects. So for example, coordinate frame will return, it won't return a sky coord, I've just realized, but it will return a coordinate frame object. The date will return an AstroPy time object, or the exposure time will return a AstroPy quantity. And so, as well as being user-friendly, one of the advantages of adding this abstraction layer is that it's, in theory, agnostic to the implementation underneath. So if a new standard comes along that supersedes fits, not that it will anytime soon, but if it does, we could keep this layer, the API of this layer, the same, but just swap out how we handle the metadata under the hood. So that is kind of the philosophy behind what the metadata is, and then how we use that in a map. So very briefly, some issues we've had with this approach. So SunPy often internally modifies the metadata. We do that in map sources. So for example, down here, I've got an example of loading a HMI map. And previously, there was no way to see what SunPy was doing, what was being changed, until SunPy 3.0. So we added the ability to track these changes. So this is taken from the example gallery. So you can see when we load a HMI map in the top code block, we can then query which items have been added, removed, or modified from the metadata. So you can see at the bottom, in our HMI map source, we're removing some nan values because they're not consistent with the fit standard, and otherwise AstroPy would raise a warning if we didn't get rid of these. And we're also correcting the B unit value. So in the original file, this is as Gauss, but that's not a fit standard unit string. So we just correct that to capital G. So that is a change that's recently happened to metadata. And then two other issues. So this is an issue that Albert opened. And essentially the issue is the meta dictionary is a mix of different sorts of values. So there are values we trust and we use. In some cases, there are incorrect values which we know are incorrect. So I think one example of that is in AIA headers. There are certain sets of observer keywords which we know are incorrect and therefore have to deliberately ignore. There are values that have been overwritten, so that's either internally in SunPy or by the user, and there are values that have been added, and there are other cases. So essentially in one dictionary, there's no way to distinguish between these different values. And then,
sorry, David, to clarify, just to jump in there and clarify, is it that this allows you to see that something has been added, but not for what reason and what the state of the current change is? Or is this before the history has been made available?
So this is still the current case. So I guess maybe
okay.
Added values is an overwritten value, so perhaps not good examples at the moment. But there are, I guess my point is there are different categories of metadata as well. So for example, there might be information about processing history of the map, which is a different type of metadata to the fits WCS metadata. And at the moment, there's no way of distinguishing between those. And then the other issue which I raised, and there's been a lot of discussion about in the issue tracker, is so there's the having all these properties on map is a really nice abstraction layer for reading metadata, but we currently do not support using that layer to write metadata. So as an example, at the moment, if I want to set a custom observer coordinate on my map, I have to transform it to heliographic Stonyhurst, and then I have to set the free relevant fits WCS keywords. So I have to know what those keywords are, I have to know what units they're in, and I have to know to transform to heliographic Stonyhurst. Whereas,
and you also have to know that you're not an AIA map.
what do you mean by that?
That code example wouldn't work if it was an AIA map.
You have to know what keywords are relevant for that particular observer. Right?
Okay.
Yeah.
Because, as you mentioned earlier, AIA uses a different set of keys for observer header. So if you do that on an instance of AIA map, it would ignore it.
Right. Okay.
It would ignore it, wouldn't error, and let you know that you've done something.
No, it would just silently ignore it.
Yeah, you'd have to strip out the HAE coordinates that are in the header. And I think it will fall back on the Stonyhurst ones.
Yeah, it will. It will, if they're not there.
But you'd have to strip out the other ones.
And so what I personally would like to see is we get to a point where we can add setters to the properties, so I can just set the value of the observer coordinate to a sky coordinate, and internally SunPy deals with the fit stuff. Okay, so there's a couple of issues. And so a possible solution, and perhaps I'll read through this and then we can discuss. So this, I think, was suggested by Stuart on one of the issues. And the suggestion is that instead of using the fits metadata dictionary as kind of the ground truth, we convert that up to high-level Python objects and use that as the ground truth metadata. And so we can either do that from trusted fits metadata or assumptions and map sources, for example. And writing the metadata is done by setting these high-level properties. So it allows you to select trusted fits values to put into the ground truth metadata, and also quite nicely leads to the concept of what I like to think of as backends. I'm not sure if that's the right technical word, but
serializations is probably
okay.
More, but either works.
So essentially, yeah. So you have a standard in which your file stores the data, and you can go back and forth from SunPy to that data format, whether that's fits or potentially ASDF, or maybe there are others.
Sorry, David, could you just again clarify, just as some people don't know and other people do, I'm not a map expert. So could you just clarify what you mean by selection of trusted fits values as ground truth? I'm a little bit lost in quite what you're proposing here.
So I guess we so at the moment all the properties are drawn directly from the fits metadata when you request the properties, right? So when I access the WCS of the map, the property will go into every time will go into the fits metadata, and construct that when you request that property. Whereas what I'm proposing is we create a WCS object as soon as the map is created, and then ignore the fits metadata from then on.
Mark, though, yeah, I mean, in some ways, well, not only that, but you will actually delete the fits metadata from the list of metadata, right?
Yeah.
Because you convert it permanently into a Python object representation of that metadata.
Yeah. So yeah, that's all I had. If people have questions, clarifications they want, or just want to discuss it, then yeah.
Yeah, I just want to add or ask a question. So, if say you create a WCS object and and a standalone, and it doesn't refer back to the fits metadata every time, is the idea going back to the previous slide, or actually on that slide where you said a ground truth, like you keep the original metadata then as a ground truth that you can refer back to? Like you could do reset metadata or something, and you could just reinstantiate everything if you'd sort of done change upon change upon change. Is that, or am I completely missing the point?
So I think you could always save a copy of the original metadata as it was read in. But I think the goal would be that map doesn't inherently doesn't rely on carrying around fits metadata. It just relies on carrying around Python objects.
I see.
So is the idea that like you would have, say, a like .observer coordinate, and it wouldn't, that then you could change that easily without having to worry about how the different specific fits files are written. So that for AIA, it would be easy to change without having to know that it doesn't use the HTML, like those keywords. Is that the idea?
Yeah.
Okay. That's cool.
Or that observer coordinate never has been represented as a fits header and never will be represented as a fits header.
Mm-hmm. I guess the problem, not a problem, but like a thought, just thinking out loud, like if you were to save this as a fits file, then, I mean, it's not really that much of a problem, but I mean, how would that work then? Would I just create a new fits header from those Python objects? Yeah.
I think so, yeah. So we would have to write a set of code that would translate from the Python objects back to the fits metadata. But for example, if you loaded in an AIA map and we took the coordinate information from, say, from the keys we know are correct at the moment, and then saved it back, you wouldn't get the same header that you read in. If that makes sense.
Yeah.
So we would, I guess, consistently write Carrington coordinates for the observer coordinate if we were saving a map.
Cool.
So is it true at the moment that I'm sort of extrapolating a little bit, but from what I've heard, it sounds like that map is still inherently tied to fits.
Yes, I think
It is
so.
at the moment.
Right. So I can't just have my own WCS that I create in a Python session and instantiate a NumPy array and then create a map. It has to be somewhat fits compliant.
You can construct an AstroPy WCS object and pass it to the map factory, but what the map factory does is convert it back to a header and then pass it to the map, which then makes a new fits WCS object every time you ask for it.
I see. Okay.
So what you can't do, for instance, is pass a GWCS object into the map constructor because there's no way for it to serialize that to a fits header and pass it through.
Right. Okay. I'm sure that makes sense from a certain point of view.
Well, I mean,
but from that exact use case, it doesn't.
map has been based on .meta being a fits header since since before I was involved in SunPy, like the first version of the map class that was ever written assumed .meta was a fits header, and every other decision taken since has kept that assumption alive. So
yeah. And is the proposal here to? It sounds like the proposal here is to entirely break that, and to like make it agnostic, right?
Yes. Yeah.
So you can have a reader that translates from some sort of, you could potentially have like an ASDIF reader into map, whereas at the moment the map factory seems to, if you give it a file, it assumes it's not assumes, but it supports it being a fits file.
that's an interesting question. Does the map factory support reading ASDIF file? I don't think it does, but it should. Because you can save a map to ASDIF, but it still saves a fits header. Anyway.
I was going to say, what's all that ASDIF IO code then? If
I don't think we ever hooked it into map factory.
sorry,
because the thing is, you could put a map inside an ASDIF file, but anywhere in the ASDIF file, because the ASDIF file is an arbitrary tree, so it's not as simple to read as like a fits header. You would have to load the ASDIF file and then look through this thing that you've just loaded to see whether there was a map instance in it. But it's worth opening an issue to track that, because we should probably do that. Anyway, that is an aside.
How broad a discussion, or how broad a scope is this discussion allowed to go?
Go wide, Danny. Go wide.
Yeah, I don't know if this is something that's obvious or that's something that's very controversial, but I mean, we're talking about map meta here, right? What about like SunPy meta or solar meta or whatever? You know, I mean, is there scope for there being like a standard meta API for like, it doesn't matter whether it's map or time series, but time series is always a little bit of an outlier, but you know, like spectrogram or whatever. What is it?
Really? I mean, a time series could have an observer location. Although that observer location might vary in time, which is an entirely different kettle of fish. But
yeah, that's not so much meta anymore, right? That's more like coordinate.
Yes. Well, I mean,
I suppose that's an overlapping distinction. But
yet another reason why time series should use AstroPy table, because then you could stick sky coord in as a column. Anyway.
That's a really good point, actually. Thinking about the data that's available now.
But I mean, I suppose what I'm thinking is that, like, sort of preempting the discussion that we're going to have after this, with map being rebased onto ND cube. As far as I can see, there is an argument to be made, whether it's the right decision or not, to effectively map. You sort of get rid of the idea of map, and you just have like an ND cube with like a specific metadata object, because it sounds like so much of what map provides is actually kind of metadata translation along with visualization hooks and tools. So if we're talking about map meta, do we actually, again, this is what I was asking about scope, is the scope actually just a general like SunPy metadata object then we can then give to, you know, a spectrogram or an image cube or, you know, an image collection of passbands and stuff, and effectively it's just an array, coordinate transformations, you know, and this meta object that all the instrument specific and data type specific translations or information is actually in that meta object.
I guess the design challenge is you have to decide what properties you're going to have on the metadata object, right?
Right, of course, yes. That's a big discussion, of course, but is it something inherently different to deciding what properties you have on a map?
So I think there are a couple of things here. One is what David just mentioned, right, which is a spectrogram might want to standardize extra metadata elements than our general, right, you could imagine ND cube in its most general sense when used with solar data using one of these SunPy meta objects. And they have the most basic, most general set of metadata that we think apply in every circumstance. But then maybe map and other spectrogram objects or other things want to subclass that and add more metadata properties which return different Python objects. But I think the other biggest thing that we haven't really spoken about yet here, which is where the complexity comes in and will probably remain maps specific, at least in the short term, is there are methods on map, specifically rotate as the main example, where the metadata needs to be modified under some transform. And those modifications are probably the trickiest component of this whole thing.
Okay, but either putting that to one side or even not, you could still have like an image meta object that inherits from basic SunPy meta that has all like the things that we think always needed. And you can have all these mix-ins, like, where you have like spectral meta and image meta and temporal meta or whatever. And so depending on what physical properties you have, depending on the type of instrument, you can sort of build up this meta object and a lot of the complexity. And, we'd sort of try and standardize these names in the same way that a lot of these properties on map are effectively metadata abstraction layers, but just put it on a .meta object rather than on the data class itself. That doesn't seem incompatible. It seems like it's just shifting it to a slightly different location, which makes it a lot more easily separable if you want it to be. Is this controversial or is this obvious? Like, is this discussion already been had?
I definitely think there is scope for that. David, anybody else?
Yeah, I don't. Go on.
Sorry, go on.
I'm trying to think of it. I guess my brain is kind of working in implementation mode, and I was trying to see how you would implement that. But I like the idea. I do like the idea, though, that you have pieces of metadata that are specific to a 2D image taken over a finite amount of exposure time, and those pieces of metadata are different to, say, pieces of metadata you would have for a spectrum. So having different objects for is that what you're trying to get at? Having like different objects for different subsets of dimensions in NDQ?
Yeah, that's consistent, I think, with what I'm saying. I guess to first order, what I'm kind of saying is to make a more stark separation between the data and metadata, in the sense that like we have a data object that has a metadata object attached. And so instead of saying, okay, this data object has properties that refers to this Fitz dictionary, and having that on the data object itself, the user always know, okay, metadata, I do .meta whatever. And then that gives you the scope to have, various mix-ins of metadata objects. And so, yeah, you can mix and match and sort of go back to what you said, to have sets that are specific to your different physical axes or your specific instruments or specific epochs or, whatever is needed. You can sort of create this metadata object ecosystem rather than this linked and sort of interwoven and entangled data / metadata object.
Shane,
Does anyone have a a feeling for how complicated it is to map from a generic observer metadata, generic WCS back to like FITS compliant headers. I mean, obviously with WCS, it's not too bad, but like, for example, if you give it an observer coordinate, like, I guess it wouldn't be that hard to just map it back to the standard FITS keywords.
I mean, in FITS WCS, it should be like, it should be very doable, right?
Yeah.
But if you're outside of FITS WCS, then that might, obviously that would not be.
Well, it depends then, doesn't it? Okay, so, I mean, there's lots of things to think about here. And I think while Danny's point about making this more general is valid, I would, for the sake of our own sanity, probably suggest that we start with just focusing it on map and bubble things out as we go or afterwards. To me, there are kind of three main components to this. There's the actual metadata object that exists as .meta on the map, which is like the user API part. Then there's the serialization and deserialization part, which is reading it from a file into that metadata object and saving that metadata object back to a file. The types of those two files do not have to be the same. There is no reason why you couldn't read a FITS header and then save a bunch of Python objects into an asdiff, not as a FITS header. So you have pluggable serializations for metadata objects. Like you could read from an asdiff and save to a FITS, except you probably couldn't. But that's an important component, right? Is that a metadata object, depending on what the types of the Python objects are, determines from and to what you can serialize. So you could read an asdiff file and get a GWCS object as your .wcs, which is fully 8.14 compliant, and therefore SunPy will work with it perfectly fine. But there's no way to save that GWCS back to a FITS file, so you can't serialize that to FITS. So if you try to save it to a FITS, it'd have to throw an error going, you have a thing that can't be saved to a FITS. I can't save it to a FITS. Would you like to save it to an asdiff file instead?
But I mean, is that what this discussion is about? Are we trying to untie ourselves from FITS?
So I think,
or do we, at this point, do we need to do that? I don't know.
I don't necessarily think that untying the serialization to FITS is necessarily a high priority. Like, I don't think there are many maps in the world that aren't coming from a FITS file. But what we want to do is we want to, at the moment, maps operations, rotate, etc., as well as loading and all manner of other things. The underlying data model is a FITS serialization. All of those things modify a FITS header directly. So if what we want to do is we want to change map so that it no longer cares whether there's a FITS header there or not.
Well,
Yes.
I think David's suggestion of having, enabling some sort of like getter setter functionality for modifying the metadata, I mean, that goes a long way towards solving those problems, such that our .rotate or resample or whatever methods don't care whether metadata is FITS or not. They're modifying the relevant bit of derived metadata, and then if we're dealing with FITS keywords underneath, then that will be taken care of by the metadata layer and not that specific method.
Yes, agreed, with one caveat, which is applying rotate to a WCS as an example of a really gnarly thing to do. Applying rotate to a WCS is implementation specific to that WCS type. Right? If you apply rotate to a FITS WCS, you change the PCIJ matrix on the fits WCS object, and then you've rotated it. If you want to apply rotate to a GWCS object, that is more complicated and may not be possible.
Well, like in that case, okay, so then this might still be an issue, but like say then you would modify, like when we do a dot rotate and you align your pixel and world coordinates, then you set your like rotation. We already have like the derived rotation matrix, right? So you set your rotation matrix to the identity, right? And then it's up to the underlying metadata model to say how does that setter correspond with the underlying like keywords, I guess.
Mm-hmm.
And maybe still doing that for GWCS is difficult. I don't know.
Yeah, that's kind of what I was thinking. Where you would have a metadata object that knows. You would have a wrapper around fits WCS that would let you rotate it. And you would have a wrapper around a GWCS that would let you rotate it, or whatever else you have.
Yeah, like I think, I mean, David, you can tell me if I'm wrong, but I think like that in your like proposed solution, then like it would be in all of our methods, it's replacing all those lines where we're setting fits keywords, because all of our properties derive from fits keywords. We're then setting properties instead, and then we're deferring the details of how that translates to the underlying metadata to some other layer separate from our map. I mean, is that essentially what your proposed implementation would boil down to?
So you're thinking of like rotate, or
or resample, or places where we are modifying keywords directly in those methods.
I think rotate. No, so I think rotate and resample are. So as Stuart said, rotate would have, if you call rotate on a map, the way it modifies a fits WCS and a GWCS would be different.
Mm.
So, like in a GWCS, there isn't the concept of a PCIJ matrix that you can set.
Right.
So I think you still have those as methods. But for things like the big beginning date and end date, exposure time and observer coordinate, it would give you a way of setting those without having to worry about whether you have a fits WCS or a GWCS underneath.
But yeah, I think that's what I mean, is that our map methods have no concept of, they don't care like what a PCIJ matrix is, right? That level of granularity is deferred to the metadata level and not to the operations, like the data operations on the map. I guess that they're modifying a derived like rotation matrix property, and then that the metadata layer differentiates between PCIJ and whatever a GWCS equivalent would be. In like this, I guess, in the setter. Yeah.
Sorry, go ahead, Stuart.
I mean, I think we're falling a little bit down into an implementation hole, but at some point we probably need to cut this off, but maybe we're not there quite yet. There's an interesting like layer violation thing here in my head, right? Which is the WCS is a component of the metadata object. We have a metadata object. One of the attributes on the metadata object would be .wcs that have to return an AstroPy 814 compliant WCS object. Rotate modifies the WCS. Resample modifies the WCS. So it feels like a layer violation to put a rotate method on .meta, because you could have some stuff come from that looks like a fits header and some stuff come from a GWCS, right? You could have the exposure time object could come from a dictionary in an ASDIF file, but the WCS came from a GWCS object in an ASDIF file, or so I almost feel like we need a WCS, like we need a map-specific WCS wrapper class which can modify WCSs. So that you're calling a .rotate method on a WCS instead of calling a .rotate method on the metadata object.
So is that equivalent to saying, to separating out the WCS from the general metadata, effectively to say we have metadata and we have coordinate data, and that coordinate data is a separate, unique type of metadata, so that it lives on its own, separate from the dictionary, the metadata dictionary, or the metadata object?
I mean, this already has to happen in IndyCube, right? I mean, this kind of leads into the second half of this state, right? That separation is already going to happen if we move to an IndyCube.
Right. Well, that's exactly why I was asking that question, to understand, how that fits in here.
Yeah, I definitely think I even might have an issue open on AstroPy or SunPy about separating. Given a fits header, can you just tell me all the keywords that are WCS specific, so I can separate those out from the rest to interpret the coordinate system? So yeah, I definitely think that is a valuable thing to do.
But that would be the job of the fits deserializer for the meta object, right? We would have a meta object, and we would have a fits deserializer that takes a fits header and returns a meta object. And inside that deserializer, it would have to construct various objects and remove or move the metadata keys from the fits header that it used to construct those objects, because that specific operation of converting some fits keys into a fits WCS object is a fits specific problem. That is not a problem you would encounter in other serialization formats necessarily.
Yeah, but I think it's worth some nice seagulls in the background.
Yeah, I feel like kill them.
But yeah, I guess that's an advantage of relying on Python objects, is that you can take a fits WCS or a GWCS independently from the rest of the metadata.
So
yeah,
go ahead.
I was going to say, if we were going to do this, I haven't really thought about how to go about it. I guess I'm keen to add setter properties to setters to lots of the properties on map. But then I don't know how independent that is from the serialization and deserialization.
Those are very linked together.
But I mean, until we untie ourselves from fits, maybe we don't need to worry that much about the serialization, deserialization part.
Cool.
Or do you disagree?
I would argue that we practically can't do setters until we've disentangled our serialized, deserialized steps. Just because that is a nightmare. You could sit down and do it, but I think it would be difficult to maintain and would just be digging ourselves a deeper pit. If we're going to do this, we might as well do it properly.
Is the deserialization and so on, is this sort of moot if we were to say we don't support writing a map back out? A map is for like putting data in, and
We no longer support saving map to fits. You will only save your map to asdiff, and therefore we don't have to write a fits serializer, and therefore our problems are solved.
it's not a suggestion, it's a question. Is all of this discussion because people want, or we want people to save their work back out into fits? Is that true, or is that not true?
So there are two steps. We would have to write a deserializer. Now, map already has large chunks of a deserializer in it, in its various properties. But there is extra work to be done there to make the deserialization permanent rather than a view into the fits WCF, into the fits metadata. Right? At the moment, our deserialization is deserialization on the fly, as opposed to a transformation of that metadata. Right? The metadata is not transformed upon deserialize. It is asked questions of to deserialize it. Right?
Well, it's just a lazy, yeah.
Yeah.
They're all
So
lazy.
Coming back to it, that AIA observer example is an excellent demonstration of the point I'm trying to make here. Right? Is at the moment we calculate observer coordinate by looking at the fits header and going, that's an observer coordinate. There you go. The deserializer into a metadata object would have to check the header for every single supported observer coordinate, pick which one it wanted, deserialize it, and then delete the rest. And it's that last step that we're not doing at the moment.
Or even not even just delete the rest, delete all the metadata. Now it's in a...
Yeah.
Not all the metadata, sorry. All the observer
Yeah.
metadata. Yeah.
Yeah. All you'd have to like identify all observer metadata keys and then construct one Python object representing them and remove them from the metadata. When I say remove, what I probably mean is put in a different dictionary, but for the sake of argument, remove, right?
Yeah, I mean, I've never tried to take the observer coordinates that are in the fits files and convert them all to see if they're all the same. But I would imagine that you would probably find some inconsistencies where, you know, the way sometimes you can have the observer location in multiple coordinate systems in the headers.
Oh yeah.
And so then you'd like read it in from the one that you trust. But yeah, I mean, I'm just saying that, yeah, I can see lots of edge cases where you'd find fun problems.
So that brings us to a different point, right? Which is that these deserializers are source specific. So we would need a deserializer for AIA and a deserializer for HMI to account for this kind of deviation, right? Which is one of the things the properties do at the moment.
Right, that seems to be within the scope of like this ecosystem of metadata objects, right? I mean, like the factory already does that for reading different like files from different sources.
Well, it's the map sources themselves that do it, not the factory, but yes.
So, well, yes, okay, yes,
Just
that's
to be
absolutely
a
right.
pedant.
No, you're right. But yeah, like if anything, that kind of more bolsters the point, right? I mean, we have these like map sources to read data. I mean, conceptually having like metadata instrument specific mix-ins or however it's implemented is completely within the ballpark.
So, like, I'm just trying to imagine something. Imagine you read in an AIA fits file. Okay, that's fine. You do some stuff to it, and then you want to write it back out. Obviously, you won't get exactly the same fits file, but does that mean that we could like make it easy to write properly fits compliant files?
It would only ever write properly fits compliant files, and it would probably only ever write the observer coordinate out in one frame, for instance.
Yeah, because that could be kind of useful in itself. to be able to fix things. But then if you read that map back in again, it would have to construct the same or equivalent metadata, which I guess it would.
We kind of do that now.
We do.
It's just
Kind
that we
of.
still carry around all the original,
Yeah.
or most stuff that would. There are things that are removed, I guess, so most of the original metadata, but it is still fixed. And then when you write it back out, it's compliant.
Mm.
So I guess if you had that metadata like object that had everything in it that you needed to make a map, and then just write that out, and then it should be easy to read back in then. Is that the idea? Like at the moment, can you take a map and I mean, I don't think you can do this. You could just print out the keywords that it's actually using to generate the map and to do everything with it. Is that a thing you can do at the moment? No. But that's, I guess, what we want, right?
Yes.
Yes.
Or it's a side effect of what we want, maybe.
Yeah.
Yeah.
Can I just ask a question again in a slightly different way? Why do we support writing maps out to fits?
Because everybody uses fits and wants to save their maps back to fits.
Do they?
Mm-hmm. Yeah.
Yes.
Yeah, for sure.
For example, like say you're prepping your data, and then you prep your data, and then you want to write it back out to a fits file instead of having to like read in those files, prep them every time, and.
Yeah, I mean, like for FTL, that's what half the project was: reading in a bunch of AI or HMI images, deproject, rotate them, and then write them back out to fits, because that takes a long time. You don't have to do it over and over.
Mm.
Now, I wouldn't mind serializing out to ASDF or NetCDF. Like it doesn't bother me what's written, but you definitely want to be able to save maps after you do stuff to them.
And I think the community probably would fits, right? I mean,
Yeah.
if they're in fits in the first place, it's like
I think the key point here is that we're only ever likely to be able to save something to fits if it came from fits.
Right.
Because fits is far and away a lowest common denominator of serialization format. Right. The fits metadata, like a fits header is stupidly simple in terms of what's on disk. So,
I mean, I will say that being able to construct a map from like a data array plus essentially a dictionary does make serialization to other formats extremely easy. Like say if you want to stick these in an HDF5 file or something like that, that's dead simple to do. And then you can do. I mean, you have to do that yourself. SunPy doesn't need to provide that, but it does make it easy to do that. Or something like ZAR, or I mean even ASDIF. If you want to do that yourself, that's easy to have just data dictionary and then reconstruct your map from that.
yeah, I mean, we probably shouldn't get too much into the relative merits of the fits format at this point, but suffice it to say there are reasons it is like it is, and that is one of them. But so the conversion, I have a thing actually. I'm going to post into the coordination meeting thing, and I'll post it in the Jitsi chat as well.
But like, just a silly question: if you have a map and you have it in this nice format where you have your meta object that contains all the necessary information, and it doesn't matter how you write it in, but it all kind of reads into this thing. Why would it be so hard to write that out to a fits file?
Because you can have ways of describing a WCS that are not within the scope of fits. So a GWCS can be an arbitrary function.
Oh yeah,
and there's no way of describing an arbitrary function using fits.
Okay.
So if you sort of just insisted that underneath, is there a way? Yeah, you can check that the WCS is a fits WCS type, right? Apart from that, I think all the all the sort of non-coordinate, all the other metadata, right? Say all the WCS metadata information is like in a separate space, like .wcs, right? Everything that's left is if it's come from fits, it's effectively a dictionary, right?
Yeah.
So
Well, maybe, but not necessarily.
Yeah,
I'm
you
trying
could
to
do all sorts of fun stuff with strings and then code and things.
Well,
Mad-
I mean,
bad-
you could
bad
have
things.
you could have a situation where something you want to read. I'm trying to think of an actual concrete physical example, and I can't. But some property of your instrument could be described by a single Python object that's read from many fits keys. Observer location is one, but that's borderline WCS, so it's difficult. Like, if it's a fits WCS, it probably is WCS, but if it's not a fits WCS, it might not be in the WCS.
I guess what I was trying to lead towards was that you only support writing out a map to fits if the WCS is a fits WCS, in which case it's kind of like the infrastructure is there to make it fits without that much trouble. And if the user changes that, well, then that's you got to know what you're doing. Sorry.
Yeah, I think that's true. I think there would be a fits serializer, which takes a SunPy metadata object. It looks at the objects that metadata object contains. So, like a WCS object. It looks at the type of that WCS object and goes, do I know how to save this to a fits header? And if it goes no, it throws an error going, no, not for you.
We're at the hour right now, and we have like a 30-minute break in the schedule before we start the NDCube 2.0 discussion. But one of our outcomes that we wanted was to decide and document internal structure for storing maps plus metadata. I think maybe obviously we have what was on David's slides, but maybe we should think about kind of more concretely the plans for implementation in the next session about how this would work. I think it's hard to separate this discussion if we're trying to rebase, if we know we want to rebase on top of NDCube to sort of disentangle this like implementation wise this discussion from the NDCube one. So I think maybe we should think about having at the end of the next session more of somewhat of a plan for implementation when it comes to metadata.
I would point out that, in my opinion, the NDCube stuff and the metadata stuff are orthogonal. You can have either or both, and you can pick and choose happily. Because NDCube gives exactly 0 hoots about what's in its .meta attribute.
But then doesn't NDCube
almost
care
deliberately?
Doesn't NDCube care about the WCS though?
Yes, but you can tell it to shut up and use the .wcs property and override the constructor. So you can get around that.
All right, well, let's break now before we go down this rabbit hole, and then come back in half an hour. So 16:30 UTC.
Okay.
Go.
All
Thanks,
right.
David.
Don't know how you can all wait that long.
Waiting with bated breath.
Yeah, I don't
All
know
right.
it's a half an hour. Maybe it's my fault. It's half an hour and not 15 minutes.
I think
Anyway,
half an hour is
It gives-
great.
That's great, yeah.
Yeah, it gives time for Shane to get his second beer.
I don't have any beers.
I
Danny.
thought
wish
that's
I
why
had
the
beers.
camera was off.
Lemon flavored water.
All right, I'll talk to you guys in half an hour.
See you in a bit.
agree.
Yeah,
Live streaming is on.
but
It's on,
I feel
everybody.
like in
It's
this session there probably will be opportunities, Albert, for you to jump in on hypercube and hyper stuff, because map is, I suppose, a very specific,
Live
potentially a very
stream.
specific
Come on.
instance of ND cube going hyper. All right.
I don't know what we want to do with regards to the metadata discussion. After when everybody went for a break, I wrote a whole bunch of stuff down on my notepad. Do we maybe want to move into a more implementation focused discussion on Friday or something? Or do we want to leave Friday for other things?
I'd be happy doing some implementation discussion as part of the hack day on Friday. Yeah.
Well, so one thing I wanted to, like I said, I couldn't unmute this morning, sorry. But one thing that I felt was under discussed was what is our responsibility toward preserving metadata? This notion of like when we load in a file and people save it back out, the file's intended to be used in other pipelines and still like largely function as the original source file, minus stuff that we say is blatantly wrong or something like that. But like do we keep metadata that we just don't know whether it's right or not? Do we a comment you made, Stuart, about like only having one observer coordinate, but other pipelines might need the other observer coordinates or expect them to be there. And so is SunPy supposed to be like the end point and saving it out to a file is just kind of, yeah, great when it works? Or are we trying to like work hard to preserve the spirit of the file that we are working with?
I think that's a very good question.
Yeah, I mean, as a concrete example, I know that all of the solar orbiter fix files have a requirement to have the observer position in a set of different coordinate systems. Like it's a requirement when we make the fix files, even though they might be wrong. In fact, they should all be there. So yeah, I mean, someone might be relying on them in a certain coordinate system, and if we dump them out, they might not be happy.
And of course, that's actually a tricky one, because at least for some duration, Solar Orbiter actually had the wrong coordinate information for one of his frames. And so what's our responsibility for preserving that, or like working with that? Do we always offer it up? Do we just strip it all out and just say, this is the trusted friend, it's the only one we're going to put out? Kind of like I think Laura made a comment about like preserving only the metadata that's necessary to reinstantiate the map class. That's a different kind of perspective than perhaps like, again, trying to trust everything or trying to at least preserve everything. Because we don't know how the data is going to be used past once it's out of our hands.
Two comments come to mind immediately. One is if you're solar orbiter and you want to save your observer coordinate out in many different ways, you could subclass the serializer and always use that specific instance of the serializer. And the other thing is, like, to me, the untrusted, unknown metadata thing is fine to be carried around and saved back out again until you've done something like rotate. In which case, what is that the point where we maybe consider throwing that away? Because if you've manifestly modified the metadata in some way, is it up to the user to copy over the unknown metadata at that point?
Well, I mean, ideally, I would say every instrument team should be saying what they want SunPy to be spitting out. Kind of like what you're saying about subclassing the deserializer, right? If we had that kind of engagement for every single instrument source, then this would be fine, right? Every team gets to make its own decisions about what does the save method actually preserve. The problem is right now we don't have that level of engagement.
But I mean, even facilitating source-specific serializers is interesting because it means you have to preserve the source through the pipe. So the question becomes: is the metadata object truly instrument agnostic, or like is it completely agnostic, or do you want? And if yes, how do you preserve information about the serialization in the metadata object?
I guess if you just explicit when you write out the FITS file that in a comment or in the history or something, it's like this has been stripped back. This was written out this way by a SunPy. I don't know.
The way I see it, once you put it into SunPy, it's a SunPy object, right? So you want to read out that it's kind of irrelevant what was in the original file. You read out the data that's in the object. Now that still doesn't fix everything because you're still going to serialize and deserialize. But how much, unless I misinterpret you, Laura, you're talking about trying to write out the full history. Okay, you went from this file. I'm going to tell you in some kind of comment section. This is how we got to.
No, I mean literally just having this was written out using SunPy map.save, so that people are aware it's not the original file. But I mean, people should be aware anyway just by reading it. But I mean the same problem is someone could read in a FITS file at the moment, change all the metadata and write it out, and it's still wrong, right? It's up to the user, I guess, to be aware of what's going on.
Which I think is fine, because someone can do that without using SunPy. Someone can read it into using AstroPy or anything, create a new FITS file, and go around masquerading. Oh, this is the original, STO FITS file, and it's not. I mean,
yeah, exactly.
I don't know if that's SunPy's problem.
I think it's also possible when you write a FITS serializer, we can say, by default, we're just going to write the values that we trust and use. But if you want to, we can put in all the original values that haven't changed as well, if we keep a copy of the original metadata.
Yeah, I mean, if you keep a copy, when you serialize it back out, you could check for all of the keywords that you know how to write back out, and write them back out if you know how. And if you don't, well, I mean that's or if you can't because it's changed or it's been deleted, that's a different thing.
I think there's a difference between unknown metadata that we haven't processed, which I envisage just carrying around as a dictionary, and other things that we have processed.
But how do you reliably differentiate between those two, or do we need to differentiate between those two?
I think we'd have to differentiate between those two. I think the serializer has to remove from that unknown list anything that it passes or anything equivalent to what it passes,
which is
to the best of its ability.
Source-specific serializers and deserializers, essentially, because you need to know what bits of stuff.
I mean, you definitely have to have source-specific deserializers.
So it's basically, I mean, like we've said, the data sources are already that. We have that. We just don't do it on the right end.
So I know we're supposed to be talking about IndieCube at this point, but if I can share my screen.
Yeah.
So just to sort of give some context about where the questions I was asking earlier, and maybe this might lead into what Albert's hyper meta comment was about. This is an example of how I wrote a metadata object in SunRaster. So there's just this general metadata module, and it starts off by just defining a number.
Just up the font size a bit, Danny.
Yes. How's that?
Yeah.
More?
No, that's okay for me. I don't know anyone else.
Okay. I kind of wrote that. I don't know why I didn't sort of bring this up earlier, but when I originally sort of wrote this, I had in mind as this being like a sandbox almost for something that might be applicable to more broadly in SunPy. But this meta ABC is an attempt to try and define, okay, what are the tags that are going to be common to basically everything? So detector, instrument, observatory, start, end, and then defining by observation type, like remote sensing, and defining these tags or slit spectrograph, and then these are all ABCs. They're just defining what the API is, and then in the SPICE module, which is inside the instrument subpackage, there is a SPICE metadata that inherits from one of these ABCs, and inside this, you've just got, these sort of hidden methods that just translate from, the fits header to, into this API. And so you access, whereas some of these sorts of things might be available on map.observer or map.instrument. In this case, they're available on, like spectrogram.meta.instrument. So this was kind of where I was coming from earlier, and I don't know if this is at all helpful with this whole idea about source-specific metadata objects and source-specific serializers, if this fits into this kind of discussion.
The user-facing API I have in mind is basically what you have there.
Okay.
The implementation is quite different.
For this, is the user-facing API then? Is it when I want to access like observer radial velocity on a SPICE data object? Do I do object.meta.observer radial velocity, or
exactly?
Okay, so it's explicitly on the metadata and not on the object.
And what this means is that you have a generic spectrogram object, which happens to have a SPICE metadata object. So everything on the data is sort of generic, and then basically everything that is, in this particular example, everything that is instrument specific is on the metadata object. But again, this is inherited from a slit spectrograph metadata object. So you have this subset of all slit spectrograph instrument or data types will want these keywords. And this in turn inherits from, this remote sensing one. So you end up like cascading from the most general, which is, like instrument, for example, or observer location. These are like, fairly general. You can argue about these specific ones, but the principle is you cascade all the way down to like, the most specific data type, and then finally you implement that in an instrument specific version. So you will again have, as well as all the ones you've inherited, you can create, I'm trying to think, yes, SPICE observation ID. This is clearly not an inherited one. This is something that is specific to a SPICE metadata object. So you can end up having the data type is generic, but attached to it is an instrument specific or source specific or, data type specific metadata object. And you can have all sorts of methods and things attached to that based on what you need. But it separates those two, the data and the metadata. Does that answer the question?
Yes. Yeah.
Okay.
Answers my question.
Okay. I don't know if this had it related to what Albert said at the start, that hyper meta. Or sorry, is it Albert?
No, I mean, hyper metadata would be a very underdeveloped concept even in my mind. So don't run too far with it.
Okay. Or if Stuart wanted to say something about how this looks similar, but underneath the hood would be entirely different.
Mostly by that, what I mean is I envisage moving the metadata properties on map onto the .meta object.
Right. Okay.
So we deprecate map.observer coordinate and replace it with map.meta.observer coordinate at some point in the future.
Why? Out of interest.
Partly for this reason.
But I see. Well, that's implementation, right?
No, that's API.
Well,
it's both.
Well, yeah.
But shouldn't you?
Why did you make the API decision to have them as properties of the metadata and not properties of the entire map?
Because then you end up having, I think you're restricting the scope of the problem, right? So like if if you want to, you then have to have like source specific data objects when inherently the data is treated all the same. Like it's a NumPy array or a Dask array or whatever. The only thing that's different from instrument to instrument in this example is just how you sort of read and translate and handle the metadata. So instead of having a bazillion ND cube types, you just have these metadata types, and you can attach whichever one you like, to your ND cube or to your map or whatever. So,
well, I will say that not that Skycore should ever be the model necessarily of how you'd ever want to do anything, but you could bring the attributes up, right? They don't have to be literally declared on the ND cube class. Whatever your metadata class has and the properties it has can be elevated up so you can actually get them at the map level.
Yeah, like why would you have, or from an API perspective, that seems just more things to type in between my object and the thing that I want. Everything is I'm sticking .meta in between all these things. Like why as the user do I need to know explicitly that these things are on the underlying metadata object instead of just the thing that I'm using?
I mean, I have two facetious answers to that question, which is explicit is better than implicit, and there should be one and only one obvious way of doing something. And then sure, I have a less facetious answer, which is like I think it allows us to be more flexible with what we want map to be. Like Steve and I had many discussions over many years about having physical type-based maps. So you have a different map for a magnetogram than you have for an intensitygram or whatever. And I think if you've moved the metadata properties out of the map API, it gives you much more scope for customizing the map API because the metadata API is the same. It compartmentalizes the API and potentially allows us to do interesting things in the future. It's namespacing. It's a namespacing problem, right? You're accessing something about the metadata, so why would it not be on the metadata namespace rather than on the main namespace thing? Anyway, we do not need to have this discussion now. We should move on.
No.
This is like not even an implementation question because, as Albert says, we can implement it in a backwards compatible way and then have the argument afterwards. So we are so far away from having to make a decision on this point that we should not discuss it much further, I don't think.
Okay.
All right.
Does anybody have anything else to talk to bring up on the meta thing before we move on to Cube then?
Or we completely lose our minds.
Yeah, if anyone wants to try and hash out some more details on Friday during the hack day, then I'm keen.
Yeah, I'm keen. I will say that I posted in the chat is LSST have a version of these deserializers, which I looked into many moons ago, and I think is, if not a promising dependency, is a promising bit of inspiration for how I envisage the deserializers working. So if people want to have a look at that, it's worth looking at. Cool. Let us cube.
All right. Is my screen being shared? Can people see it?
I can.
Your screen is shared.
Yes.
Great. Okay. Yep. So let's we're only just getting started with all this fun. So what I'm going to do in this few slides, I'm going to give a rapid reintroduction to NDCube. I know it gets talked about a lot, but I also know that details get missed and things can be confusing. So I'll very quickly reintroduce us all to that. I'll give a quick update on where 2.0 is at. And then I will talk about mapping map to NDCube, by which I mean, what are if you want to do something with that you're used to doing in map, how would you do it with NDCube? And then I just want to throw open the discussion for a proposed map, which inherits from NDCube.
Would you just mind me butting in quickly?
Of course, please do.
Just so that people keep it in their mind, what I had envisaged the outcome of the next hour and 40 minutes being is general agreement on the contents of a SEP, which would be a proposal for the required API changes to map to make this work well. I'm not proposing we actually write it, but if we're all vaguely on the same page about what potential API changes we're looking at for map to make this inheritance work well, if somebody writes up a SEP on Friday or next week or something and opens it, nobody is particularly surprised.
Okay. And also, is there someone taking notes for this session?
Yeah, I'm on them.
Thanks, Laura. Okay. All right. So very quickly, NDCube, the package. The point is to provide a standard API for handling generic ND, astro, and solar observations. To do this, it provides 3 basic data classes, NDCube being the fundamental one, which is for basically a data array plus a WCS. That's all you need. NDCube sequence, which is for basically an ordered set of ND cubes. And then also, which was relatively new, is ND collection, which is effectively an unordered set of ND cubes. There are 3 primary sets of functionalities that this provides. All of these are agnostic to the actual physical, the actual data types, but are very common and are going to be used over and over again. The first one is extracting and identifying regions of interest. So this is done through slicing, indexing, and cropping to inspect and quick look the data. So we have visualization tools based on that leverage the WCS and the data array. And then also mapping array elements to real-world coordinates. And so we have coordinate transformations that heavily lean on the WCS object. And the hope is that this simplifies and speeds up the workflow of either pipelines or of people's analysis, and also reduces mistakes, because these things are done over and over again. If we just rigorously develop them in one place and everyone else uses them, we're more likely to do things faster and more accurately. So just what exactly is an NDCube object? Here you sort of see what's inside. We have sort of 4 main things. We have arrays, which you see in blue. We have coordinate objects that you see in red. We have metadata that you see in green, and then visualization and data inspection methods that are there in yellow. So NDCube has a data array, an uncertainty array or uncertainty object, and a data mask. We have the WCS transformations, which of course we're all aware of. In addition to just .wcs, NDCube has 2 other coordinate objects. First of all, extra coords, which is sort of serves 2 purposes more recently. Firstly, if you want to work with coordinates that are like arrays rather than sort of continuous functional coordinate systems like WCS. If you really want arrays, then extra coords hopefully provides you an easier way of internalizing those into your data object and slicing them and all the rest of it. But also, as of NDCube 2.0, extra coords can as well, but doesn't have to be represented as a second WCS. And so, we can link extra coords into various WCS frameworks if we want to. So the third coordinates object there is global coords. This is envisioned as an object to handle scalar coordinates that don't correspond to any particular axis. So an example of this might be if you have a 2D map, you have a timestamp. That's obviously a coordinate in real world, sort of real world space, but there's no third time axis, so it doesn't correspond to an axis. So a scalar time object would be a great example of something going into global coords. Then we have meta, just a unit data, and this metadata object, as was mentioned before, but I think it's worth saying again, seeing as a conversation we've just had. NDCube at the moment, nothing alters or interacts with the metadata. So NDCube is completely agnostic to what's in there. And so this as well was motivating some of my questions about moving all these attributes onto the metadata object, because it just sort of makes both implementation and, at least to me, logically it makes the namespace sort of a bit more sensible. Okay, so just as a very quick example, one of the benefits, by the way, people interrupt if I've said something that's confusing or you want a clarification. But just as a very quick example as to what benefit this can provide, if we have this container object called ndcube, which has all these things together, we can build functionalities that handle everything in a logical and quick way. So instead of slicing all our uncertainties and our masks and all the rest, and alternate changing our coordinate transformations, for example, we can just slice an ndcube object by employing the standard Python slicing API, and that filters down and slices all the arrays and alters your coordinate transformations accordingly. So that's a very quick benefit of this kind of data model. Any questions on that so far?
Yes.
Is there anything confusing? Yes.
For slicing, have you implemented support for both fits and generalized WCS objects?
Yes, so this comes to the point of, this actually comes to something I want to say about ndcube 2.0, and that is the main motivation was the adoption of the AstroPy WCS API, namely 8.14. And one of the things this has enabled us to do is to upstream a number of features. One of them is slicing WCS. So now, so long as ndcube requires an 8.14 compliant WCS, and so the slicing of the WCS object is actually upstream now to AstroPy, whereas previously, we were doing that sort of fairly manually and explicitly on ndcube, and I think might have only really worked for fits WCS. But now with 8.14, this provides a number of different benefits, this standard API and all this extra WCS machinery that AstroPy has provided through that. One of them being the WCS slicing. But to facilitate this, it required a number of breaking changes for ndcube, and so this is what's triggered 2.0, which is a major sort of root and branch rewrite, which is API breaking. Because once we decided that we're going to break things, it gives you the scope to look at the lessons learned from 1.0 and say, well, what was done well, what was done badly, what made sense at the time, but is now doesn't make sense because the world has moved on. And so
also, this sledgehammer is real fun.
Yeah. Yes. If by fun you mean putting lots and lots of effort in and the goalpost continually seems moving away from you. But it is quite exciting when you see the extra power and capability that sort of emerges out of this sort of complete sort of reforging of the of this package and of the basically just taking the lessons learned and saying, well, let's have a second go with all the extra knowledge that we've built up. So some of the examples, you've already mentioned that one about slicing WCS objects. ndcube is now agnostic. It doesn't care whether it's fits or DWCS or anything else. So long as it's 8.14 compliant, it just doesn't care. The changes also bring the API into line with 8.14 in certain naming conventions, so that people are getting already very used to the 8.14 API, I think. And so changing the API for ndcube to fit in with that, I think, is probably better for user experience. And yeah, hopefully all of these changes will simplify and enhance the user experience overall. So very briefly, this is not an exhaustive list of what's new in ndcube 2.0. We have this global coord class that I mentioned earlier for scalar coordinates that don't correspond to any axis. I think this was particularly motivated by if you slice out an axis, like you say you have a map cube and you slice out, along one map along the time dimension, what happens to that time information? It was a coordinate, but now it doesn't correspond to any axis because you've gone from 3D to 2D. So holding on to that information was a big motivator for this global coords idea. We've completely changed how the implementation of extra coordinates. Before it was a dictionary of dictionaries. Now it's like a full-on class. And this has allowed us to do a number of things. We now have an ndcube.combine WCS that combines all the extra coordinates with the WCS information into a single WCS object. So you can combine them if you want to, but you don't have to if you don't. It's also allowed us to unify the cropping API. Previously, we had crop by chords and crop by extra chords. Now it's just crop. We use high-level data objects when we're, by which I mean things like sky chords and time objects. So that is more in line with 8.14. But we also have like a values API, for example, crop by values, in case you still want to use the lower level objects like quantities. So like I've already mentioned this, we've brought some of the nomenclature in line with 8.14. We use sort of array index. The 8.14 now talks about world, pixel, and array index, where basically array index is the inverse of pixel because of the way of how WCS has its axes inverted relative to the data. So this is all just making it, if this doesn't make sense to you, that's fine. Just learn the new way. Don't worry about the old way. But it is sort of somewhat breaking if you're used to the old way. And then we also have improved pluggability, I think, or what we hope is improved pluggability for the visualization suite, as well as many other things as well. So the status of 2.0, we have basically 3 remaining issues. We need to confirm that crop works as it should, given all these changes. Hopefully it does, or if it doesn't, it's an easy fix. And after that, it's basically documentation to make it easier to read. So tidy up our representation strings and also develop some docs for people who want to subclass NDCube and just give them a helping hand in how to do that. So I don't know how long it'll take in time, but in work, it's very close, I think. So finally on this, where is like NDCube 2.plus is where is NDCube going? Well, we have a GSOC project running at the moment, which is working on a reproject and hopefully ultimately a resample method on NDCube using the reproject functionality. I think this is going to be particularly useful for map if we're talking about rotate or like differential rotation or anything like that. And something that has a little bit of work done, but I think is more of an aspiration at this point is supporting arithmetic operations. So potentially adding, multiplying, dividing, subtracting different ND cubes or maps. So I've got a PR open in AstroPy, which starts the work of making this possible to do, but it needs more PRs and more work. So that's longer, longer in the future, this stuff.
Does reproject work in more than 2 dimensions?
Yes, as long as
Yes.
you're using the interpolation method.
Cool.
That's a good question. Any other questions on this?
Because I think it's going to be pertinent to the discussion in a little bit. I just want to quickly elaborate on your pluggable plotting API bullet point there.
Yes.
What that PR has done is moved the implementation of visualization onto a dot plotter property of the NDCube class. That dot plotter object now has all of the visualization code on it, so you can implement extra plotting methods or on dot plotter. So you can do cube dot plotter dot draw me a Pikachu, or you can go, actually for this cube, matplotlib isn't the best thing to visualize this with. I'm going to replace it with PyVista and assign an object to that dot plotter and use a different visualization suite. The only thing that still exists on NDCube is dot plot, which is proxied through to dot plotter dot plot. So as long as your plotter class implements a default plot, the NDCube dot plot kind of defaulty quick look function method still works and still exists. Those of you who understand my feelings about the visualization API on map will understand why I wanted to elaborate on this a little bit before we move on.
No, I appreciate that. And I know you've put a lot of work into that. And I think it's finally showing now that PR has got to where it's got to.
PR was surprisingly easy once I'd learned what a descriptor was and how to write one.
Any other questions at this point? Because I think, as Stuart mentioned, some of this I can race through, but some of this may well end up being pertinent in the discussion. So if there are things that are unclear, it could help us in a few minutes' time. Okay, we can always come back to this if people want, or if it becomes relevant. Okay, so now I'm just going to quickly just basically just show if you want to do like something from map, how would you do it in NDCube? But first, I'm just going to give my interpretation of what the main things map does. And I know that there are a lot of map experts here, some of whom may be appalled at how much I've reduced this. But to me anyway, map does a number of things from a user point of view. It reads data from different sources. It creates this metadata abstraction layer that we've been talking about so that there's a reliable constant API for getting, say, observer coordinate, irrespective of which source it came from and if it was stored in slightly different keywords or whatever. So that's all important. Neither of those things, I think, is really within the scope of, or the underlying implementation is not really within the scope of NDCube. But other things are. So a standard data access API. So your data, for example, is stored in .data or .wcs or .meta. NDCube has a very, very similar standard data access API. Visualization. Sorry, go ahead, Stuart.
Just quickly, the reason that NDCube has a very similar data access API is because NDCube and map both have the same parent class, which is AstroPy NDData.
That's exactly right. So yeah, that will make it very easy to switch over, I think. So another thing is visualization. There are a number of like plot settings, as David mentioned earlier, and also sort of the .plot method or the .peak method that sort of allows you to use matplotlib and show this data. This is something that is within the remit, as we've discussed, of NDCube, and also cropping. I know there are other things that map does, but to me, from a user point of view, these are the big sort of like analysis sort of points or classes of features. And the ones here in bold, I think, are things that aren't actually or don't have to be specific to your physical types of your axes. And NDCube, I think, kind of proves that you can maybe do it in a slightly different way, but basically do the same thing without making the assumptions that map makes. So why do we want to rebase, or why are we proposing to rebase map onto NDCube? Well, firstly, NDCube provides this standard API not just for 2D images, but potentially for all or most SunPy data types. I think one of the burdens or one of the barriers to creating more data types in SunPy has been that map has been this flagship object and is clearly very useful, but has taken up a huge amount of effort and work. And I think the idea of starting from scratch with a different data type is probably off-putting to some people. In fact, it would be to me. But if we have this system where we have the standard API, we can quickly spin up other data objects if we want to. We can keep all the sort of the axis type or axis agnostic functionalities in NDCube, and it just sort of centralizes and makes things easier and quicker for us to maintain and develop. Additionally, NDCube provides a number of some things that map doesn't. For example, slicing, as I demonstrated earlier. As far as I'm aware, map only allows cropping. The nomenclature here, I I kind of use is cropping is when you're defining a region of interest based on real world coordinates, whereas slicing is using the more array index way of going.
So map, just to confuse and bewilder, map submap function does allow pixel inputs.
But as real world coordinates in a weird way,
No, as
right?
pixels.
Oh, it does now. Okay, great.
But it's not using the array Python slicing notation. The submap method allows you to specify corners in pixel space.
Right. Okay.
An important but kind of arbitrary distinction.
Okay.
Important
All right.
distinction because it's one of the things on the chopping block. So, you know.
Sure, of course. No, that is an important distinction, because effectively what NDQ provides is sort of, I would argue, a more intuitive but nonetheless a different way of doing effectively that. So that would be a significant, that would be a shift in mindset from people who are trying to do this type of operation. So yes, NDQ can also easily be extended to higher dimensions. For example, there's no, if you're basing everything at ND cube, a map cube with an extra time dimension, the API would not significantly change. It should be intuitive for users to go from a 2D map to a 3D map cube. And that ND cube sort of provides, is sort of agnostic to the number of axes, so a lot should carry over. And also, at least we hope ND cube is easy subclassable. So they're the motivations. Are there any questions on that, or any other things people want to like push back on what I've said, like they're about the slicing? Is there anything else I've said that's wrong, or have I represented map unfairly in any way? Okay. All right. So this is just for.
Sorry,
yes.
Quickly, I would add, as we were discussing earlier, I think a feature of map you missed on your list earlier was saving. So I was going to ask at some point about saving ND cubes, but maybe this is the question for later.
I would say yes. That's a question for later, but definitely a question that should be addressed.
Cool.
I mean, there's a short answer, which is it's on the roadmap.
Mm.
It doesn't yet work.
Yes. But it is something that then there's a discussion as to whether you want to explicitly put that onto some sort of map subclass of ND cube, or we want to put the effort into to putting that on ND cube itself as it states on the roadmap. But that's something that we can discuss. Okay, so I've got a few different areas here, sort of explicitly mapping between map and ND cube. The first category is data access. So these tables just show what's common and how to access common things. So your data array in both cases is .data. Your mask in both cases is .mask. You can access WCS information via .wcs, and metadata is .meta. So again, this is all, as Stuart mentioned before, because both of these objects inherit from AstroPy ND data. And as far as I'm aware anyway, map doesn't really sort of implement in uncertainty, whereas NDQ sort of explicitly does support that. If I'm wrong on that, feel free to contradict me, but can you do map.uncertainty and then get an uncertainty
Yes, because
array?
it inherits ND data, but nothing in map actually does anything with uncertainty, so also no.
Right. Right, okay. So if you do map.submap, does it check uncertainty exists and then slices it for you?
No.
Right, okay. So in that sense, it's not supported, whereas in that sense, it is supported by NDCube.
Yeah. Okay.
Data inspection, if we want to check the dimensionality of our data, map.dimensions returns a named tuple or a pixel pair. I think the thoughts for this was to be explicit as to which is X and which is Y, given in certain situations, Y is first and X is second and vice versa. That works with the assumption that you have two dimensions. It's easy to disentangle. NDCube does not make that assumption, so exactly the same call will give you the same information, but as a quantity, and it assumes that you know the ordering of the dimensions. In addition to this, I guess because map sort of was always assumed to be two spatial dimensions on the, in helioprojective or some kind of helio coordinates, I don't think that it easily gives you the physical types. Maybe you have to dig into WCS for that. Whereas NDCube provides this array axis physical types, and this gives you back a list of tuples where each tuple corresponds to an axis, and inside the tuple is a string of types, because you can have multiple physical types corresponding to each array axis. So that's data inspection. Again, stop me if there are any questions on this. I'm flying through it a little bit quickly, but we can come back to it if people think about a question later. So plotting, yep, you can do map.plot. You can, and that returns an axis image object. Exactly the same way you can do ndcube.plot, and this returns a WCS axis subplot. So it's a different return type, but from the ndcube version, it is quite easy to extract the axis image object if you want to. So ndcube does not prevent you from doing things the way that they were done in map. There's just an extra step required. Now, to expand on this, as Stuart mentioned before, the implementation of this is actually that there's an ndcube.plotter, which has all various sorts, which can have various sorts of weird and wonderful plotting methods, but ndcube.plot just defaults to the plotter.plot method. So as it stands, you could argue that map and ndcube can be made to be very, very similar in this respect. In fact, default to being very, very similar in this respect. So it can be very simple to change over, or we can completely change stuff if we want to. I don't know what the status of map.peak is, but there's nothing similar. There's nothing similar to that in ndcube. Likewise, map sort of carries around sort of plot settings, so like which color table to use because it knows it's AIA 171 or whatever it is. Of course, ndcube is agnostic to all that, so it doesn't. But if you provide that information, through the plotting, as like keywords or whatever to plot, then you can still make an ndcube.plot look exactly like a map.plot.
I think it might be interesting to add functionality to map data to colors, which is still a back-end agnostic operation.
Sorry, say that again.
To map your data values to, say, RGB values. And then you can, so for example, in PyVista, you could use that, or in Matplotlib, you could use that.
Oh, I see. Okay.
Yeah. Obviously, not essential, but I think you could do that in a back-end independent way eventually.
Okay, and that was a feature request on Cube.
Yeah, more issues. More activity, that's great. Okay, and then penultimately, I think, cropping. If we want to extract, as we've kind of mentioned this before, if we want to extract a region of interest based on real-world coordinates, we can use map.submap with almost exactly the same API. You can do that with ndcube.crop using sky coords and time objects and all the rest of it. If for whatever reason you don't want to use high-level objects, you can use quantities via crop by values. That's probably going to be more useful for some reason to developers, but maybe not. But the point is, with just a rename of the method, that same functionality exists. And then, as we've already discussed, slicing. Map doesn't support the standard Python slicing API, whereas ndcube does. And then finally, coordinate transformations. There is actually a way of doing this in map using a function rather than a method, and I can't remember what it is, and I didn't look it up. But if you want to get the real-world coordinates for all pixels, there are explicit methods on ndcube to do so. Axis world coords. Again, this one returns high-level objects, whereas the values one returns just quantities. And I know there is a function somewhere that you give it a map, and it will do the same thing for you. But
yeah, it's map. Well called. Craig posted a question in chat, which is, does ndcube slicing support every nth slices? And the answer to that is no, because what you want to happen to the coordinate information is ill-defined.
Yes. That's exactly right. We did sort of think about that very thing, and basically decided that it was, or realized that it was ill-defined, and that the things that we were thinking of initially were actually assumptions. And I mean, you could, again, talking about subclassing, for some reason, if you wanted that assumption hard baked in, potentially you could.
Yeah.
You could hack it, but I'm not sure we would recommend.
I mean, it depends what you do. Yeah, and what you can do slicing wise with ND-cube is significantly more limited than what you could do slicing wise on a NumPy array, because it has to be able to be applied to the WCS as well as the array. And
right.
It is, yeah. So you can't do like NumPy fancy indexing, index with an array of booleans,
right,
for instance, or similar. Yeah, pick out a random pattern of pixels, because ND-cube, or unlike X-array, for instance, ND-cube always maintains the WCS as a WCS object. So you can only perform slicing operations on the cube, which can be performed on the WCS.
However, there is... Sorry, is there a comment there?
Oh yeah, sorry. Are you limited to like contiguous chunks then? Is that the limitation?
Yeah, basically yes. However, there are / will be ways to not to get around that, but there's sort of a different way of achieving effectively the same end. So if you want every nth point, another way of doing that is to just mask out every, or to mask the array, but unmask every nth column or every nth row. So you would still have a contiguous data array, but you can use that mask then if you want to do calculations using only every nth column. So the mask can help you do that if you're trying to do calculations. Another then way of doing that is if you wanted to change the dimensionality, or like you wanted every nth column, but you wanted that to be like a sum or an average or something like of that, of the interval that every nth column represents. Then you could use resampling, which is not currently supported, but as I mentioned before, there's a GSOC project that is working on the first implementation of that. So that would effectively reduce the dimensionality in the same way, and would allow you to control the way that the data value that comes out for that column is returned. But it isn't using that slicing API. Does that answer that question? Or Stuart, was there anything you want to add to that or correct?
No, don't think so.
Okay. All right. So yes, sorry. Yeah, I suppose, were there any other questions then before I sort of basically wrap this up and hopefully open up a broader discussion?
Can you do the equivalent of superpixel? So like merging, I guess you had a cube merging, like a cube of 2 by 2 by 2.
Not at the moment, but again, that is very much explicitly one of the motivations for the reproject and resample work is that's happening now. So no, not now, but the intention is that you will be able to do that.
Cool.
So that is something else that map does, right? Isn't it? Has or had superpixel?
Yeah, it has superpixel.
Has superpixel, yeah. So that is something that is not yet done, but that should be and will be. Okay, so what does a map based on ND-cube look like, and what needs to be done? So here's a strategy that I haven't run past anybody. So Stuart, or anyone else, if you've got some pushback or some other ideas, please, this is where the discussion starts. So my thoughts were that, I suppose on the right, I'll start on the right, that all the axis agnostic, or at least most of the axis agnostic functionalities can be provided by NDCube. We've seen how the data access API is basically the same. We've seen how you can do, although the API is slightly different, you can still do slicing and cropping, effectively region of interest selection. We've got coordinate transformation support for our pixel grids. We've got almost the same and some additional data inspection methods. And there is a default visualization suite that maybe is good enough for map. In the future, as we've mentioned, reprojection, resampling, superpixel, all those things are related. That's being worked on at the moment. And then I don't think map supports any kind of arithmetic operations between maps, but in the longer term future, that is something that would be good. I think that NDCube would like to support. So, there are various use cases where you might want to divide one cube by another. Say you've got a map that doesn't represent an image, but represents some sort of image quality or exposure time, or depending on how your image is put together, and you may want to divide one by the other or subtract a background or something like that. So that could be good in the future to do. At the moment, you can probably just do that by doing that on the array before you create the NDCube. And then on the left, what is the role of map? Well, NDCube is definitely not going to give you a library of data readers like for AIA or anything else EUI. So maybe that remains within the realm of map, or maybe someone wants to say, well, we need sort of a library of readers, which is not the map factory. That I think is beyond this discussion. We need a metadata translator that we've been discussing, an abstraction layer, effectively. So I think whether that's the map object or whether that's what we were discussing at the very start of this session of moving all of that stuff into a metadata object, I think given NDCube setup makes a lot of sense, but isn't the only way or isn't required. As well as that, some Solr-specific analysis tools like differentially rotating your image that would rely on the underlying reprojection infrastructure of NDCube. And then also potentially visualization if map wants some more specific visualization tools for images or for 2D images. There's nothing stopping map saying, because we know we have this image type or this data type, there are assumptions we can make, or there are performance enhancements we can make, and we want to implement our own visualization. So that's question mark on both of those. That's purely a preference decision based on requirements. So this is just to say what still needs to be done. So NDCube SEP that Stuart mentions, that's pull request 51 on the SunPy SEP repo. And as apart from that, we need to release 2.0, the main blocker at the moment being the finishing of the testing of the crop functionality. And then apart from that, maybe things come out of this discussion that we realize that we need to do before map can inherit from NDCube. So I'm just going to stop there, and hopefully people are caught up and have the context they need to agree basically on this this SEP, which I think, as Stuart mentioned, is kind of hopefully the goal of this discussion, is to tie this down.
I was thinking of actually different SEP, to be honest. But
oh, were you? Okay.
I am, for the purposes of this discussion, planning on taking that as gospel, because everybody has had a very long time to comment on it, and nobody has in a significant amount of time. So I am expecting that the NDCube SEP is merged as is. If people have opinions on the shape of the NDCube API, now is very likely your last chance to go and review this PR.
Okay, so which one were you talking about then?
A new one.
Oh, a new one, just that doesn't currently exist.
Yeah, so
okay,
we can kind of hit off this discussion with a few things that I noted down during Danny's talk, which is some to obviously SunPy could inherit ND cube pretty much as is, override everything that we don't want, and maintain the API almost exactly as it is at the moment. Some of that would be stupid. We would have a submap method and a crop method at the same time doing the same things in different ways, and that is silly. So the first thing that is on the chopping block is submap as a method. Submap would be removed, and crop would handle cropping by world coordinates, which for map would be sky coords, and the slicing API would handle cropping by pixel coordinates. Does anybody have any comments or objections on that?
With like deprecation periods on the existing
Sure.
methods, right?
All of this will have to be deprecated and handled correctly. I'm going to work on the principle that, this is what we're discussing here. Mostly is end goal, unless there is specific questions about being unable to deprecate things.
Cool, great. Yeah, just wanted to double check.
Also, I just wanted to go on a very brief tangent. Although we are talking, before we get too in the weeds about map implementation, I saw Matt was on the call earlier, sounded like Craig gave in a question. If there are things coming out of this that you would like to give some extra context for your needs, I think having in the back of our minds that, potentially a map object based on ND cube, could have, other end users, not just SunPy itself, I think is an important facet to keep in the back of our minds. So I would welcome their input throughout this as well if they have comments to make.
Hi, Danny. This is Matt here. I've got a bunch of questions, but just to respond to that one, I was actually wondering if it would actually be constructive to have a kind of side meeting with you guys where we can actually specifically discuss Punch's needs to see if you think it actually kind of fits in with how you see ND Cube going.
I'd be really supportive of that. Very, very willing. And I think that.
Yeah, I didn't really hijack this whole meeting just for Punch's needs, but I do have some more kind of like open questions which I'd like to bring up in a little bit when we move more on into the Q&A section.
Okay, well, yeah, I think we're kind of like merging into that Q&A at the moment, but I think it's fair that Stuart continues with his list, and let's come back to Matt's list. I think that's probably the way to go. Do you think that sounds reasonable?
Sounds good for me, but I'm gonna be on mute. I've got noisy neighbors at the moment, so
okay,
quiet.
Great. So yeah, submap deprecated by crop is the first big API change that map would need.
Can you sorry.
No, go on.
Just can you remember me again? So you have an ND cube and you do crop by chords. You pass it quantities rather than sky chord objects, right? Or
that's crop by values, but I mean, effectively just think of crop. I think.
So like if you sorry.
Go ahead.
No, I was gonna say like just if you have a map and you can do dot crop, can you pass it pixel values as quantities or like real world values? I know I've done this before and I've forgotten again. But,
the hypothetical future here would be dot crop would take sky coords.
Okay.
Dot crop by values would take quantities in arc seconds. And if you wanted to slice based on pixel coordinates, you would use the indexing notation.
Yeah, gotcha. Okay.
Yeah. So only real world coordinates go into crop/submap. That then also can filter down to plotting API in the sense that if you only want to like plot the x-axis from pixel 3 to pixel 7, you do cube 3:8 dot plot.
Mm-hmm.
So it gives you that kind of it sort of allows you to to use that API even more broadly as well.
Definitely, yeah.
I've written that down, but I don't think that's actually true. I think the only other thing that would happen without, or the only other kind of major API change that's worth talking about is the behavior of the plot method. Mostly its return value. Currently, as Danny pointed out, NDCube returns the axes object, whereas map.plot returns the axes image object, which is the difference between the axes and the output of the IM show call. Matplotlib IM show returns an axes image object, whereas NDCube currently returns the axes. So that's one thing to bear in mind, but I think there is a bigger discussion here about visualization in general.
Also, just to point out, just to reiterate, that you can get the axis image object very easily from the return. So it doesn't stop you using that, but it does change the default behavior. So anything you've already built won't behave quite the same way.
I will point out that changing that return type is very difficult to deprecate. Or at least very ugly to deprecate. I will say that map also has a lot of other plot methods. And if we are going to go full NDCube, as it were, the logical thing to do would be to move all of the draw underscore methods onto the dot plotter property.
I think having that separation from the visualization stuff from everything else in map and using the kind of the dot plotter approach is really nice.
But yet you didn't want things on dot meta. Curious juxtaposition of opinions there, Will.
Don't persuade him the other way. But yes, that strikes me too.
But I think that what is in line with my objection previously is that I still think you should have that dot plot alias to make a plot. I shouldn't have to go dot plot or dot plot. If I want to do more complicated stuff, sure, it's fine to kind of be aware of this separation. But I think having a dot plot method that returns me a picture of my data in some sort of representation is still a valuable thing.
Yeah. This is why we kept dot plot in existence on NDCube.
I lost that battle. Yeah. I feel like there should be only one way.
You could come out peak.
That was my other comment. Was going to be like, I think we should burn peak to the ground, and we should never look back.
Yes, that was also on my list.
I mean, you say that, Will, but what you're asking for is kind of like a dot peak.
I know.
Yeah, but it's actually more useful. I know it's only one method.
But that's I was gonna say that's my objection, is that because we talked about this the last coordination meeting, is that people confuse peak and plot and don't really understand, because they use peak and they get out a thing, then they don't realize there's a plot method as well. Whereas something like the quick look method gives you something completely different. It's still really useful, but it's completely different than probably what you want in, say, like a publication quality or publication quality plot, say. So you're like, oh, if I want that, then I'm going to go to dot plot, right?
Oh yeah. I should also. Sorry, is that Laura?
No, Danny, go ahead, sir.
I was just going to say, to follow up on that, the requirement for ndcube.plot or plotter.plot is not to create publication quality visualizations. It can, but it's not a requirement.
Sure.
I believe the exact wording in the docstring is should strive to provide a summary of the object or something.
Yeah, something like that. So like if you can get, I mean, like as we always do, right? When you're making a plot for a paper, like you do everything very manually, because you want it to be very precise for this one plot for this one paper. So,
but I think like the map, I guess if we're moving all of the kind of plot functionality that's in map over onto like a matplotlib plotting mixin, if I'm using the right words here, then that should still give you the same kind of capabilities that we're providing users now on plot and all that to make like the figures you want for your papers, say.
Yeah, in the sense that it's not peak. It does allow you. It does sort of open you up to the full sort of matplotlib range of functionalities, and so you can use that combined with various other things to create something. Yes, that's true.
We could even consider splitting the current map.plot method up into pieces. We could have a map.plotter.imshow method that just does a WCS axis aware like imshow call, and then .plot could call that. I'd have to have a look at the code to really crystallize this idea in my head, but we could break up plot. Plot does a bunch of things with like setting a title and stuff at the moment. We could move some of that stuff out. We could have a version of the method without that stuff and call it something else like imshow, and then have the main plot method combine it all back together again or something. So that if you want to build up a plot more by hand, map provides you some useful utilities to do that in stages, rather than having to do what you do at the moment is you call .plot, map does a whole bunch of stuff for you, and then you have to back some of it back out.
I mean,
like plot, for instance, puts the HPC grid on, and we could move that. We could have a workflow where that is an optional add-in rather than a remove, because that's quite difficult to undo.
That's actually
Sure. Sorry, Laura.
Oh, sorry, I was going to say that's a good point, because I think even a lot of people aren't aware that what that plot is doing an IMShow, and they're like confused then about what the hell's going on, and they don't know how to interact with it. That would be a nice thing to have. I guess another final question is like, would you only alias .plot and then keep like draw lim and everything as like .plot or .draw lim? Or where does it draw the line on that?
I would vote yes.
Yes. I voted against .plot.
So we all know where Danny lives.
Okay.
So
I'm sorry about the plotter. So if someone wanted to can someone switch between them, like matplotlib or other frameworks?
Yeah, if you assign a type to the .plotter, it's a descriptor that allows you to swap out the plotter. So there's a default that's set in the class definition, but you can at runtime change it.
Okay.
But not if you have an object and instantiated a cube, you can't then switch between types, right? Like you instantiate a cube, you can.
Yeah, it's only none you can't do that with.
Oh, okay. I see.
I understand why you said that based on our discussion in the NDQ channel the other day, but that's only true for none. You can do it at runtime for other things.
Okay.
Okay. To your bullet that you were asking right up there, I would say I may have had a different answer in the past, but I would object to returning the axes.
You'd have an objection to this?
For .plot or for something else, right? Because I kind of agree for map, because the reason that NDCube is primarily different is because NDCubes.plot handles multi-dimensional cubes, and therefore, depending on the dimensionality of your visualization, returning a axis image object is not helpful, because you might have an animation instead. So
yeah,
I can kind of go either way on that one at the moment, because it would be very easy to change it for map with a map specific plotter object. But if we're also then breaking up plot into a bunch of component methods on the plotter, having plot return the axes and having the ability to like do an IM show to get the axes image back out is also could be an argument the other way around. Why are you pro axes image over sub like?
Well, okay. I mean, again, it gets into like what the plot method really is doing, right? It sets all these annotations and everything, but primarily it's that IM show. But you know let's just say that just in the past day, I've written a bunch of code where I use, you know, like a data frame.plot, and it spits back the thing, or a data frame.hist, and I can just directly just work with that. It's not like I'm not working with the axes. I'm working with the thing that was plotted, right? In the case of IM show, it's a little bit weirder, but certainly when you talk about like draw limb, draw rectangle, those should not be returning axes. Those should be returning the actual thing that gets added to your whatever you're doing. So
yeah, no, I agree.
Is dot plot supposed to be like the whole thing, or is it supposed to be like how we use it also in some of these things where it's like, you know, especially in the world of auto align and some of the stuff that we're doing on the map side, like it's not. It's really about just like saying, you know, we want to overplot something on this existing plot. It doesn't make sense to return the entire axis. It makes sense to return what you actually are overplotting.
Yeah, no, I agree, and that's kind of always where plot was a drop-in replacement for IM show. As a counter argument, plot does a lot more than just call IM show.
I was going to say, I think the most useful thing that, at least in my experience, that the most useful thing that plot does, it sets up the WCS axes based on whatever projection your image is in. And then most of the time, if you want to get into like the nitty gritty details of adjusting your plot, you want to be using the WCS axes API, and almost all those operations are done on the axes, the returned axes itself, right? So without that, that's obviously much harder to do, and that's a problem I had using IndyCube previously. Before this was the case, is that I wanted to modify the WCS axes that the plot was setting up, but I couldn't get at it. And maybe there's another way to do that and a better way to do that, but that's been my frustration in the past with not returning it.
Given an axes image, though, you can get the axes that image is in, because there's
yeah, but the reverse is also true.
Yeah, but it's harder because there's in general a one-to-many mapping of axes to images on that axis.
Sorry, you're gonna have to say that again.
So for a given axes, I can have many images.
Yes.
But a given image only exists on one axis.
Right. So you can sort of do axes.getImage or get images, and you can then index it like the zero. It's basically a list of axis image objects.
That's unnecessarily confusing. I mean, in the context of like, if you think about line plotting and matplotlib, right? You do a dot plot command, it returns that line. It doesn't return the axes that line lives in. And so when you do multiple of those calls and you assign them to different variables, you can know you have a variable for whichever line, for each line or whatever you want to do, and you can just modify that line. You want to change the drawing style for that line, you already have that object. If you return the entire axis, you return the entire list of all line objects each time you plot another line, then you can't work in that mode of modifying the thing you just added.
Yeah, no, I agree, and I just question whether what we're actually doing here, slowly but surely, is turning plot into a summary plot where it's in reality it will return way too many things. And what we are talking about when you're talking about that kind of workflow, what you want is an equivalent to IM show, which, depending on whether overplot is true or false, returns you an axis image object or a p contour set. Like,
so are you kind of saying that what you are calling plot is actually very similar to what is currently peak?
Yeah, basically. No. Basically, the question is do we burn peak and then accept that plot is actually quite similar to peak in what it's doing at the moment? And maybe this is not a question we need to answer now. It doesn't matter. Just something to think about. Like, the more I think about it, I quite like this idea of breaking plot up into a bunch of component parts. And if we've done that, then what does do we accept the fact the plot is a summary or a conglomerate rather than just a replacement for IM show?
Well, I guess maybe this is a dumb question, and maybe we've already touched on this, but I mean, in the context of map, not in the larger context of NDQ, it's like what like in the most basic perspective, like what do we want plot to do that you couldn't just do easily with matplotlib imshow?
Well, certainly the auto aligning and p color mesh will not be possible.
or sorry, I used imshow, and by that I meant just like what's the advantage of using map.plot as opposed to here's my data array and here's matplotlib, right? Like what does it offer me?
I think what you kind of already said it. Like for me personally, just from use, is the fact that it sets up the WCS axis, and then you can do everything on that. And like I think even that plot it is at the moment, like even though it does have, when you just do .plot, it has instrument specific things. They're just in the plot settings that you can easily change. So I guess having that, like, so I think the idea then of having like plotter.imshow and then plotter.plot makes sense in both ones, you know.
So just to clarify, this pretty much all this discussion is talking about like overriding what's in ND cube. It's not like this question, which is like, you know, are we talking about changing fundamentally what the ND cube defaults? We're talking about this part, right, where we're like adapting a new like map visualization.
Okay, maybe I'm not familiar with ND cube in this context, but ND cube, as I understand you described it, the .plot method or what a .plot method is supposed to return some kind of summary.
.plot is much closer. In ND cube, .plot is much closer to .peak than .plot is on map.
Right. So you're basically you're kind of in this mode of you're creating your own axes. You're not taking someone else's axes. You're just trying to you're doing all of it.
It bridges the gap. It kind of it depends on the dimensionality of the cube, which maybe now we've done the .plotter thing, we should actually consider changing. But I'm probably not going to that for 2.0. But if you're plotting a 2D cube, plot behaves quite similar to maps.plot. If you're not plotting a 2D cube, plot on ND cube doesn't behave similar to maps.plot at all because it has to return an animator that can scrub through the extra dimensions.
Yeah. Or a line plot if it's 1D.
Or a line plot. So there's like, you get a whole bunch of weird things with .plot. .plot is a weird API.
It's like quick look. It's like quick look, like represent all of my data in this cube in a way that makes most sense. I don't care, just show it to me, sort of way. But in which case, it's got to inspect itself, understand, well, how should I show this, and then build it all up and give it back to you.
But I mean, in that context, which again makes .plot sound like .peak, map.peak. Why does it have a return type at all?
Oh, because you can do, if you're plotting a 2D cube or a 1D cube, you can use it like map.plot.
Well, I mean, but so then I would argue that, you know, if in the world where you're talking about having these underlying plotting things, which is like specifically for like a 2D map, the plotting, you know, IM show, and I would push back against calling it IM show because I would want P color.
Yeah. IM show is a bad name, but you get my idea.
Right, a more raw 2D plotting method, and then a higher level .plot. If the purpose of a higher level .plot is kind of like how we've been using map.peak, then it shouldn't return anything. The lower level plotter would return the axis image or the P color mesh or the contours or whatever it is.
No, I don't know, because returning something from plot is so much more useful. If you just want to go with the default settings, do .plot and then like save the figure. It's just so much damn easier to return the
argument again on NDQ.
Anyway, no,
to bring it back, like just say what it is in ND cube, and I think this is getting slightly blurred because, you know, we're sort of switching back and forth between what does ND cube do and what we want map to do. But ultimately, as it is, dot plot just points to plotter.plot. So as far as NDCube is concerned, dot plot can be whatever you want it to be. It can assume whatever role you want it to, because it just depends on what. Again, if you use NDCube and then assign a different plotter, and a totally different plotter object, and that object happens to say, well, my dot plot prints hello world, that's fine. That's like NDCube doesn't care.
Yeah, I think this is more of a higher level of map discussion rather than anything to do in NDQ.
No, and that's fine.
Which is what I expected this session to be, by the way. I fully expected this session to be an argument about the NDQ, the map API, not the NDCube API.
No, I just wanted
while we're on questions that make NDCube makes us ask ourselves, I've got one more, and then I think we maybe want to spend the last half an hour talking more generally about NDCube with some of the other people who are here. I have one other question, which is NDCube, especially NDCube 2, has been forced into accepting that pixel and array indices are in different orders. And we have fully embraced the fact that pixel and array indices are in different orders, and WCSs are always Cartesian ordered, including their pixel dimensions, and NumPy arrays are not Cartesian ordered. Map historically, and NDCube now just teaches the user that in the documentation. Like that has to be something that we just teach the user. Map historically has held on to providing ways to disambiguate this to the users, and has historically done a bad job of this in various places. One of the options that we have available to us at this point is we can, in map, accept this fact and decide whether a thing is going to return in array order or world order, and tell our users that these are different. Functionally, the upshot of this is we remove spatial pair and pixel pair and decide in the docstrings of properties and other places whether a thing is array, pixel, or world ordered, and document the living sausages out of that and accept it.
In what instances do users care about this? Because I feel like when I use SunPy for my research, I do not care, or I don't use function that interacts with the ordering.
So, an example which, given depending on what happens with the metadata refactor, is a very interesting. It brings up a whole swath of other questions we could answer later. But to consider the map API as it is at the moment and not doing anything else with metadata, an example is there are many metadata properties like coordinate types. Is that what it is? Whatever it is that returns C type, the proxy for C type on generic map. What's it called?
Aren't those replaced by array access physical type in NDCube?
Well, no, because they're still part of the map metadata abstraction. Let's take, for instance, reference coordinate and reference pixel. These are two things which are a good indication of this problem, right? Reference coordinate and reference pixel return CRVal1, CRVal2, and CRPix1 and CRPix2, respectively. At the moment, they are returned in a named tuple, which provides a way of inspecting the ordering of those things, because I believe they're both returned in Cartesian order. But why don't we just return them as a tuple? And, reference coordinate be in world axis and reference pixel be in pixel order and not array order.
So
we're not coming up with an answer to this question in 0 minutes, but it's just something that has come into my head.
I have to say, having just fixed the bug where David flipped the axes, You have to be really careful about decisions like this.
I would also say from a user point of view, I was considering deprecating those properties because they are fits specific.
Yes,
but
they are
anyway,
effectively deserialize our API.
Yeah, but
But there's a broader sort of principle at play here, which is how do you, like if you do like one of them was like when you do map.dimensions, it gives you back a pixel pair. So it's like x equals 10 pixels and y equals 20 pixels, whatever it is. Whereas ND cube will just return a single quantity, with 10 and 20, and you know what it is by the ordering, because you've been educated by the docs or by Payne or whatever,
and also by the method name. And
by the method name, yes, which goes back to how we were bringing things in line with the 814 naming conventions. That it comes back in array order. So I think that's a concrete example of something that is not like a fits WCS example, but does try to not rely on ordering in that.
It is interesting to note that the only actual concrete API change that inheriting from NDCube mandates is the deprecation and eventual removal of submap. Right. On that note, we have just under half an hour left. If people have more generic questions on NDCube or map or other higher dimensional objects like the spectrogram stuff that's in SunRaster, I suggest we open the floor to that. Does that sound
or a potential NDCube map cube?
Cubes of cubes.
Cubes of cubes.
I got a question though. If you have a three-dimensional like map, ND cubes of space time, and you do like a slice along, the 0 pixel index, so you get basically what is a time series. It's still an ND cube though, isn't it? Like,
if you're using a native ND cube, yes, there is to pivot to Albert's hypercube. You could potentially create a new data class that every time it slices, it checks the physical axes and then it uses that information to instantiate a map or a time series object or whatever. But if you're using native ND cube, then that's correct. It's still an ND cube.
Yeah, I mean that's kind of what I was getting to. Obviously, it's not what we're talking about now, but it seems weird that you would do that and that you get back an object, but then you create a similar object from similar data and you get a time series, even though they're identical representations of data.
And that's weird, you're saying?
Well, a little bit, yeah.
Time series is a weird example.
It is.
Because a time series object as exists in SunPy is tabular in nature and not contiguous.
Mm-hmm.
Whereas a time series you've sliced out of an ND cube has probably come from a larger contiguous array. It's kind of like converting an X array to a pandas data frame.
Yeah.
Right.
Could you, in essence, have a time series on an ND cube object? I think that's really what Shane's trying to get at.
Yeah.
Wait,
I mean, you can have an ND cube object that is a time series.
Yeah. And you can have in your WCS a time axis, or even as an extra coordinate, and each column would itself be a 1D cube.
Is on.
So thank you for that.
It's so loud. It's just so loud.
Yeah.
I suppose what I was just trying to understand is that, like, all of our data is just ND cubes, really, of different dimensions.
Right.
Like, essentially. So why do we return different things or have different things, like long term?
You mean in SunPy?
Yes. Yeah.
Okay.
Like a spectrogram is an ND cube, a time series is an ND cube, a map is an ND cube.
A time series is really an ND collection.
Okay, well, I mean,
But if a time series with only like one column is an ND cube. Well, it can be represented as an ND cube.
yeah.
But I mean, they could all probably inherit from an ND cube. But say like a time series.
I mean, yeah, they have different like metadata and methods and stuff like that, but
Yeah.
it is the same
Right.
object. And if
So I
you,
think-
no, go on.
I would say, I think the question is now, I mean, now that we're expanding map to effectively more than two-dimensional images, it's like, what is the scope of map now, right? Like, and how, like, where does that fit into the larger scope of NDCube? Like, what? I mean, to first order, I realize that we just want to replace map with NDCube. Like, that's, you know, and not necessarily think about that. But I think that is a larger thing that we're going to have to think about at some point. It's like, where does the map API, because previously it's just like, well, anything that's not a 2D image is not a map, you know, or is not going to fit into the map API. But now, I don't know.
But say sorry.
I have many opinions on this subject, and none of them are that constructive. So I'm trying to bite my tongue somewhat. I've had this argument with many people, and it really does get very big in scope very quickly because there are so many classes that subclass ND data that make assumptions about the physical axes types. There is map, there is spectral cube, there is spectrum 1D, there is various other things, and they all make an assumption that I have an ND data object which has this specific set of spectral axes types. And sometimes that's useful. You can make logical assumptions and you can make APIs which people find easier to interact with because you're making that assumption. So for instance, Spectrum 1D has a dot flux attribute, which returns the wavelength axis. Oh no, returns the data, right?
Mm-hmm.
Because it's a spectrum. And you know that makes people's code easier to read because they're expecting to use the noun flux instead of data. However, that gets really messy when you then have iris data, where you now have space, and wavelength, and you don't have dot flux anymore, but you still have wavelength. It's all dot flux, really, right? And you end up in this weird thing, and then like the DKIS data that I've been working with can literally be anything from 1 to 5 dimensions.
Yeah.
So you can't make any justifiable assumptions about what physical axes you have at all.
But I mean, I guess that's well, partially my question. But I mean, do we want to? Are we going to say that map is always limited to data that has at least two spatial axes, right? Maybe it can have a time axis, and maybe that's a map, you know, cube or map sequence, I guess is what we call it now. But I mean, is representing like in taking your iris example, it is representing iris data as a map ever going to be is that in the scope of map or not? Now that it's based on an object that can handle n-dimensional data, should it? Right. Like what is the scope of map in terms of types, or it's really in terms of data dimensionality. I don't really care as much about data type, but about, you know, whether that 2D image represents flux or counts or whatever the hell you want to call it. Like it's more about like, yeah, what sorts of dimensionality do we want to support in map?
Well, dare I bring us full circle and open up the idea that, or bring us back to the idea that the physical axis type is contained within a meta object, you know, and then, you know, you inherently, you deal with your data generically. And, you know, if, you know, you need a dot flux, well, that's a bad example because it's a coordinate, but, you know, metadata, then you have the specific metadata objects that handle the needs of specific combinations of axes.
Extending that a little bit, I think that but if once we've got map rebased on ND data and done all the metadata stuff we spoke about and implemented reproject and resample in NDCube and a few other things, then we should probably have this discussion then. Because long term, can I see us dropping map in favor of a solar specific NDCube object that has a celestial component? Yes. Are we even vaguely close to being able to do that at the moment? No.
Yeah, I suppose you can just focus on trying to rebase map on it, NDQ, with the caveats that we've already spoke about. I was just curious.
At some point in the future, because this is not something that's going to be solved anytime soon, buy me a beer and ask me about subclasses of ND data, and I'll bore you to tears.
Cry into your beer.
Other questions on map, NDCube, etc.?
I know Matt had some questions. Oh, sorry. Go ahead, Will.
Oh, I was just going to say, before we jumped into the more, I guess, general NDCube discussion, do we have sort of more concrete things that could go into an SCP? I know that's what we said we wanted to kind of accomplish at the end of this. I mean, this slide that you're showing here, I think, sort of encapsulates some of those thoughts, and maybe some of the things from the notes. I just wanted to make sure we had some sort of that more concrete goal before we moved on to that more general discussion.
I'm sure Laura's captured some stuff that's useful too.
Yeah, I have a similar list that Danny's got on that slide in front of me as well. The submap crop one is the only hard one. We can have lots of discussions about spatial pair ordering and visualization methods. Personally, I think that we should probably consider, if we're going to make API change, if we're going to make large optional API changes when we do the end or as part of the NDCube discussion, we should probably also make any of the metadata related API changes at the same time, so that we go to everybody. Welcome to SunPy 4.1. Map, half of map is deprecated. Enjoy. In one go rather than in two goes. So
but it is
we can do the
noting.
technical transition without adding the deprecations, with the potential exception of submap, or even with submap, to be honest. And then maybe the SEP should be a more like long-term API shift for map, including any meta related shifts we want.
I guess one more thing is, like, we want to consider the fact, like, if you have a FITS file that contains a sequence of data, the moment it just reads the first image. But now, like with NDQ, that should just read it in. Would that then be supported? It should
Firstly,
just
reading is beyond the scope of NDQ.
No, but say the FITS file can read it in, and you could read in your FITS file, it gives you data and a header, and you could pass those data and header to an NDCube, and it will give you an NDCube back. But if you try to pass that to map, it says, sorry, we don't support that at the moment. And it just takes the first image.
I think the one thing, the reason I sort of made that comment was just to stress to get away from the idea of FITS files. I mean, map was inherently sort of designed, we have these FITS files, but NDCube is not. NDCube, give me an array and a WCS object and a meta, like dictionary or a meta object. I don't care, and nor do I want to know if they come from, I don't want a FITS header object. I don't care where it comes from. Just, that's the scope of NDCube. Of course, that scope, is fine for map, even if it is depending on NDCube.
Right. I'll rephrase the question then. Will we have it that map can then support like higher than like 2D data? So it's 3D data with a time sequence and like a WCS axis that describes that data?
No.
Okay.
Not as the first. Not as the first couple of steps. I think
Okay.
getting the current functionality working in the new world order first, and then consider our options afterwards, is the logical ordering to me.
I think that's probably a discussion to be had around map. What happens to map sequence too? Because right now map sequence basically does nothing except hold a 3D array, right?
A list of maps, isn't it?
It doesn't even hold a 3D array. It's a list of maps.
Yeah.
As part of the ND cube map
give you a
transition,
3D array. Yeah.
map sequence would become a subclass of ND cube sequence.
Yeah.
Yes, that's right.
Yeah.
Cool. Okay.
Which is much more useful than map sequence.
Yeah.
Especially in a couple of weeks' time, when a pull request that allows you to reproject the sequence to a cube will be opened.
Yes, indeed.
Right, time to be
You
alive.
thought, I know,
What a time to be alive.
you thought we'd wowed you with all this stuff, you know? Then the hits just keep on coming.
Yeah, Matt, have you got questions?
Yeah.
You patiently waited through a lot of technical jargon.
I'm sure I'll get through them in 13 minutes, but let's give it a go. First and foremost, what's your kind of timescale for V2 plus all your unit testing and everything?
We've been developing testing alongside.
Okay.
So, Stuart, do you want to say something on that? Well, I find
within the next 8 weeks, 10 weeks, as an absolute maximum, personally.
Okay, that's absolutely that's cool.
That is me with my deekest hat on speaking rather than anything else. It's rapidly getting to the point where I need to get ND Cube 2 released so that I can kick other deekest shaped balls down hills.
Excellent. Okay, yeah, you did say yesterday that you're under deekest time pressure, but I just wanted to see if it was yearly or weekly or monthly. But weeks sounds good to me. Secondly, actually, let's go for this one first. How does ND Cube handle memory? Because we're going to be using some pretty big data arrays because we have to combine multiple images into single images and things like that, and we want to store them in ND cubes. Now, my kind of worry is when I've been playing around with Python, I've been using like shallow copies of data rather than deep copies, and then I get I rapidly fill up my memory. How is ND Cube handling memory?
The short answer at the moment is it doesn't, because it does. Yeah. It actually at no point manipulates the data array itself.
Okay.
With the addition of the reproject method, which is currently in an open PR, that is broken because we have a method that passes off to reproject that does actual maths on the data and therefore has to have it in memory. But it delegates that to the array implementation underneath. So if you are working with a data set which is larger than memory, I would recommend you put your array in a Dask array instead of a NumPy array that allows you to do lazy loading of the memory. And
what did you just call that? A Dask array?
Dask array, yeah. Dask is a Python package for larger than memory and out of core computation.
Oh, interesting.
It is purest wizardry, and it's beautiful.
And Will can give you a demonstration of how he used Dask with ND Cube to do some cool stuff with AIA.
Oh, excellent! Yeah, of course. Yeah, AIA is massive as well. Yeah.
Yeah.
Okay, next one. You're moving on to version 2.0, and I heard you. I may have misheard, but you were talking about how your parent class is the ND data.
Mm-hmm.
The SunPy package. Is that also getting kind of how do you say upversioned or whatever it's called?
I think, well, first of all, as is the most basic form of SunPy ND data is a really it's just a container class, and it does very, very little.
Yep.
There are various different mix-ins that you can add or not add at the moment. Like ND Cube by default includes the arithmetic mix-in, but again, that's not a requirement. So the most basic form of that is very, very stable and not changing, and is very, very light. Having spoken to Matt Craig, who's the maintainer for AstroPy ND data, he told me in a couple of times, can we please just make NDCube ND data? Like, he just wants to replace ND data with NDCube and bring it into AstroPy. But of course, that takes a little bit of work. So I think the reason I tell that story is because if ND, at the moment, the most likely way ND data is going to be massively disrupted is by becoming NDCube or something very like it. Okay. So it's probably going to merge closer. It's not. It's going to, if it'll change more closely to what you want if you want NDCube, not further away.
The other thing that's worth noting is, while we're talking about AstroPy, his Spectrum 1D now inherits from NDCube.
Yes.
So.
Wow.
Yeah.
Interesting that you're kind of like flowing back upstream. That's excellent.
That's actually been a lot of what we've, over the course of this, particularly with 2.0, is a number of things that were originally developed in NDCube. Stuart has upstreamed to AstroPy or has motivated other people to develop something that recreates, what we were doing in NDCube, but better.
Okay, next one. I may have misheard, but I heard you say that saving doesn't actually work at the moment.
No, there's an aspiration to have like ndcube.save, but that doesn't, to all intents and purposes, that doesn't exist. There's like a PR where it's been tried, but it doesn't work.
And if you've created an ndcube object, I'm assuming then it's not a problem to just kind of add extra data after you've created this.
In what sense?
Well, it's just that I'm kind of we got some data products which are going to be produced over the period of, I don't know, it could be up to like 2 weeks when we're kind of like collecting data. And so save object would have been great because, we could obviously, create a .save file or whatever it would be and then just open that up next time. But what might be happening is that we are perhaps storing in memory somewhere some data, and I'm assuming there's not a problem for us to just add additional data when it becomes available to the NDCube.
So I will say that while NDCube itself doesn't yet have any decent serialization implementation, there's nothing stopping you serializing the component parts. And NDCube is made up of a data, a metadata, a WCS, and a couple of other things. That list is finite and well-defined. You can just save those out to whatever file you fancy saving them out and then reconstruct a cube on read. So,
okay.
If you fancy putting the work in to do it generally enough, you can open a PR to NDCube and you can contribute back.
Excellent,
yeah,
excellent.
The major reason that a general serializer doesn't exist for NDCube at the moment is because there isn't a serializer that can handle serializing any 814 WCS. The serializers for the WCS are implementation specific.
If you just have a FITS WCS, it's easy enough to read and write that plus your data array. That's easy to do, but I think like that once you slice, that's when you don't just have. You're not guaranteed a FITS WCS back, and that's what's hard to serialize.
Right,
or the issue I've run into at least.
And NDCube doesn't make any of those assumptions, but if you are dealing with punch data and you're not even assume certain things about the data, then you can constrain that problem to something more specific, which is not within the remit of NDCube because it's no longer really general. But suddenly now becomes an incredibly solvable problem. So you can, as Stuart said, basically come up with your own save a save function maybe that takes your NDCube and serializes it based on what you know about your data.
Okay, I see. Good. This is actually one where I probably just have to check the notes. It wasn't clear to me. Are you using? You had a bit of discussion about using Cartesian or silly coordinate systems. Which one are you using?
So the way this mostly comes into the conversation about the WCS. So in Python, things are row major. So they are
YX.
not Cartesian ordered in the
They're
array.
wrong. Hey.
Such is life. However, the 814 WCS specification is Cartesian ordered for both the world and pixel sides of that transformation, right? A WCS is an arbitrary transformation between a pixel coordinate and a world coordinate, and the WCS transformation has both of those in Cartesian order.
Okay, great.
So just to sort of elaborate on something we were saying earlier, which is relevant here, is since 814, the nomenclature, there are three main terms, I suppose. So there's world order, say, which we've discussed before. There's pixel order, which is, again, both of those are Cartesian. And then there's array order, and that is sort of row major, and the same as C and Python. So if you're in array order, or pixel order, they're effectively the inverse of each other. So by using those terms, and hopefully it becomes somewhat more clear what order you're talking about. That's why for ND-cube, it's like array access, physical types, because it's going to return the stuff to you in array order, as opposed to pixel access or world access.
Okay, I need to go and read up on this because I was completely unaware of these.
Yeah, and that's come from WCS.
Okay.
It's been thrust upon us somewhat, right? Because the fundamental objective of ND-cube and why it exists as opposed to, say, X-array is because we as a community find it useful to hold a WCS object for all of what that means, and manipulate that WCS object and keep a WCS object around mostly for serialization purposes. So the ND-cube API is built around the constraints of WCS, as opposed to the X-array API, which is built around having arrays for coordinates.
Okay, excellent. Okay, what was the next one? With the punch object that we're going to be building, we are going to have a secondary header unit to carry around extra information. And some of this is kind of born out of the fact that some of our images are going to carry information about what is good and what is bad in the actual data array. And secondly, we're going to have information perhaps pertaining to where, when we produce one of our individual images, which is comprised of multiple images, it will carry some information about that as well. How will ND-cube, can ND-cube handle secondary header arrays? Header units.
Wait, when you say that kind of thing, are those arrays the same shape as the main data array and describable by a WCS, or are they like tables of pixel coordinates?
It's not completely clear. We are going to have the primary data array, which is going to be kind of standard data array, and then we will have in the HDU1, we will conform to fit standards, and then in the secondary HDU, that's where we're going to put stuff. What we're envisaging, where we're going to put stuff which is non-standard. I'm not sure of the final data sizes, but the question is there a way to kind of carry that information within the data cubes?
Is it, to kind of slightly repeat Stuart's question, are we talking about sort of like additional coordinates? Is this coordinate metadata, or is it like...
Probably not. I don't know the answers to a lot of these questions, so we haven't really kind of like fleshed it out, and we're not that far in terms of our development. But just imagine that I want to carry some extra non-standard information.
Well, there are.
If it's, do you want to go ahead, Stuart?
No, go on, Danny. Tell him his options.
Okay. Well, so if it's sort of just general nebulous header information.
Yeah.
NDCube doesn't make any assumptions about the metadata object. So if you can create as complex or as interwoven, as layered metadata construction of like a dictionary of dictionaries of dictionaries of dictionaries, or
Doesn't
something
even have
more.
to be a dictionary.
Or I was going to say, or something completely like custom built that's a class of its in its own right. And you can store any data that you like in there. NDCube, like itself, does nothing to it. It carries it around and just leaves it there for you. So that's one option. So you've got any degree of option. If it's like a secondary data array that's not uncertainty or mask, then I think in that case, actually, what you want is 2 ND cubes, because the cube sort of represents one type of like data, one measurement.
An ND collection, right?
You want yeah, exactly. That's what I was then going to say. So then you have multiple ND cubes and put them into an ND collection.
The ND collection just shares the WCS, right? That was an implementation decision we made there.
No, it doesn't have to.
Doesn't it? I thought it did.
I
mean, you voted. You probably know.
No, I don't think so. I think it can have it doesn't even have to have any axes aligned. It can have axes aligned. It's an option, but none of the axes have to be one, or some, or none of the axes can be aligned. I need to go back and check exactly what the limitations on it are. I suspect maybe the dimensionality. There might be some. I need to double check. It's been a while since I wrote it now.
But I imagine I don't have the answers right now as to what we actually want specifically. But it sounds good that we can perhaps, for each of our data arrays within the cube, we can actually carry around some additional data in a dictionary. That's great. That's
and
kind of what we want.
And just to reiterate what I said earlier, is the use of extra chords. It was originally motivated, so that you can basically do what X-ray does and have like arrays of coordinates. But now I think it actually can serve a separate feature, which is you can have 2 sets of coordinate transformations.
Okay.
So it'd be interesting to see that used in Anger in that way, like extensively, and sort of stress that system. I'd be interested to see how it holds up. But in principle, you can have
perfect.
2 distinct. Right. Yeah. In principle, to a point, you can have 2 distinct coordinate systems that could be applied to the same data array. Maybe not simultaneously. Maybe not.
This actually kind of like feeds into what was my final question. If you don't mind, we're 4 minutes over.
Sure.
And that was you discussed earlier about the map object, which I must say I've never really kind of used the map object before. I normally yank out the array and manipulate it how I want to, and that's because I'm too lazy to learn how to use map. And I don't really use AAA data much, but when it comes to, and you were talking about how you're discussing, rightly so, that if you manipulate the data somehow, what happens to the metadata? Because if you transform it in, say, a non-affine way, you can't necessarily transform the metadata as well, or something like that. Are you going to be doing anything similar with NDCube? Will you be ever touching the metadata if we do something to the data?
As of now, no. But if you're including the coordinate systems when you say metadata, then absolutely. When we reproject or rotate or anything like that, then of course we have to change the coordinate information.
Yeah, the dot meta attribute will probably never be modified inside NDCube, but the dot WCS one could be.
Interesting. Okay, that's cool.
So so in this diagram here, there's sort of quite a deliberate reason why I've put different colors for meta and for coordinates. As far as NDCube is concerned, coordinate information isn't metadata, it's coordinate information. It's its own class of information. Metadata is basically additional information that doesn't describe or depend on the dimensionality of the data and doesn't really change when you perform operations.
For instance, if you had, there's no reason why in customizing a punch version of NDCube, if you put something in your meta that you needed to modify through a slicing operation, you could hook into the slicing operations and modify it as you need to in your subclass.
Excellent. Yeah.
Just because ND data itself doesn't make any assumptions about what's in .meta or modify it in any way doesn't mean you can't.
Yeah. Okay, so you can kind of force change it. Okay.
Yeah, I mean, I wouldn't use that phrase, but I think yes. I think what you mean, yes, you definitely can.
Cool. I think that was all the questions I had at the moment. I know that Craig wants to have a further discussion, so we can hopefully tag up at some point in the next few weeks. And
yeah, no, I would be very happy
to have a specific NT-Cube chat sometime. Let us know.
And thanks for answering the question. Sorry, I didn't mean to kind of like hijack the last 20 minutes.
No, that's fine. Nothing wrong with that.
It's good to have other perspectives on how this can be applied, because I think it can always teach us stuff.
Well, I don't know
either for SunPy or for ND-Cube,
we're all learning Python our end, so you guys are the experts. We come to you.
All you got to do is to be an expert is be 1 week ahead of the next person.
Yeah. Okay, I am teaching my nephew Python, so I'm ahead of him.
There you go.
He's 10.
You're an expert.
I see.
Anybody else have any other questions or anything before we wrap up then?
I was gonna say I took notes. I can't spell. So just wondering what's wrong. Also, like I think, like maybe Danny, if you just look through, make sure I didn't say anything horribly wrong about ND-Cube that was I misunderstood. But I think it caught most of the stuff. But yeah, I did it.
Or his main takeaway, ND-Cube is a total waste of time. We're going back to map.
No, it's Hypercube is going to take over the world.
Yeah.
Hyper about hypercubes.
Mm-hmm. Cool. Okay, I'm good, you guys.
I'm just waiting for there to be a subclass called Sugar Cube.
You have Spice Cube, so you're halfway.
I know. I've Spice Meta.
Sure.
Because of that, I'm telling you, because of that sort of design, I don't even need a Spice Cube.
Fair enough.
See you tomorrow.
Well, thank you very much.
Thanks, everybody.
Yep. Thanks. See you tomorrow.